That's better. I don't know why that changed. Lip reading classes, yeah. Okay, we should be good now. I can see audio now. I just noticed this doesn't look right. So, I don't know why that setting changed. Hopefully it didn't affect everything else. Let me check the other screens. Yeah, that's still going. Yeah, okay. I think we're alright. Check this one. Yeah. I don't know why it lost the microphone. That is weird. You hear clicking, yes, that's me going like that. So what was I saying? So as I started off with, the stream I expect is an hour later than I had planned because of daylight savings last night, and it went back by an hour. So, hey Dave. Right, so we've got here Dave, Tony, Paul, Fred, Peter, Sheridan. Haven't seen you before. Oh, have I? Oh, that's alright. That's right. You were here last time. Remember your name. That's right. Christian. Jogue? Is that Joggy? I don't recognise you either. Have I missed anyone? Anonymous Repair. It's like Chris was here, but we may pop back in later. Hey Joe. Alright, cool. Alright, I think we're all good now. Hopefully. So, I had an interesting week this week. I did lots of code. Worked on some projects I've been working on for a while. Basically, 2 days writing code, and then one of the units is something I've shown in one of those little short videos I did, which was the LoRa to Wi-Fi gateway little grey box. Anyway, I really did some code on that because I was trying to change it so the remote units normally get the time using Wi-Fi to go to the NTP servers, which takes a while to connect to Wi-Fi, get the time. It takes like 10 seconds all up, maybe a little bit longer. The first time I connect anyway. Now, problem is that I don't want it delay in there in those remote units, so when you first turn them on, they get the time, and it's like, it's holding things up. People have to wait for them. It's like, that's not good. So I've rewritten the code so now the gateway gets the time, and that then acts as a server on the network. And so I had to rewrite the code on the units to not use Wi-Fi anymore. It will fall back onto Wi-Fi if the main network falls over, but so they now use it through LoRa instead. So they send a LoRa request to the gateway, and the gateway then serves the time instead. So I basically put my own little time server into my existing gateway. And you have to rewrite the code for that. It took me a couple of days to play around because I haven't played with time setting stuff before, and I had issues with trying to actually get it to use the time correctly. So I could set the time, but then I'd read the time, it'd be the time it turned on at, not the time it actually is now. Things like that. So I ended up going through a couple of different time libraries to get the result I wanted. So I'm actually using 2 time libraries at the same time. Timely. Installed Linux, see? Get email server. Oh yeah. So what this culminated in is I got all the code working. It's all working fine. So I updated all the units, did all the firmware and everything. It's all working fine. And then when I went to reinstall the gateway for the last time, when I powered it up, I powered it once already, tested it, it's fine, and I repowered it, and suddenly it had a pop and all the smoke came out of it. It's like, oh, that's not good. And what happened, I shall show you on the bench in a minute. Actually, I might have to get a better camera out for you to see it. But the hey Chris, you did make it. Exposing vegetables to vacuum. Results have been disappointing. Okay, you might need to elaborate on that, Chris. Now, I should be streaming in 1080p as well. So let me know if that's working or not. Instead of, I normally do in 720, right? So, seeing as the last couple of streams were done, I haven't had much in the way of problems with the internet playing up. Got a bit of a foggy throat today. So I thought I'd try doing 1080p. So hopefully it's coming out in 1080p, alright? Let me know if it is or is not 1080p. I've dropped a few frames, and just initially I've dropped the setting down a little bit and it's helped. I haven't dropped much in the way of frames since then, so hopefully it's not too bad. Yeah, Chris, you've already got to elaborate on that. That's a bit of a weird thing to leave us hanging with. Exposing vegetables to vacuum. You vacuum sealing vegetables? Oh, that's this point. Did nothing, right? Okay, you wanted them to explode, right? You only get 720p. You have 720. No 1080 available. So, right. So I'm streaming at 1080. YouTube's serving 720. One that's because of my stream settings. What am I on here? If I can find the settings, it'd be helpful. I'm on ultra low latency. Maybe that's why. No, it should support it. It says 1440p is not supported, so I thought 1080 is supported. Well, in that case, I might as well drop my stream setting down to 720 since that's what I'm going to be using. I don't know if I can do it while I'm live though. No, I can't. Oh well, we'll see what happens, I suppose. Yeah, I just wanted to try and do a high quality one. I'd like to figure out why it isn't doing the higher quality. It's probably because it's got set to ultra low latency. Yeah. You getting your freeze? Okay. Oh, I'm dropping some packets now. Okay, what I'm going to do, I'm going to change my settings. And so I'm going to pause the stream, change settings, continue streaming. So don't go anywhere. Alright? Should only take me 5 seconds to change this. Okay? So, ready? Right, it should be good again. And now I'm streaming at 720. Right. Anyway. Yeah, I guess my time estimation was a bit out. So you should be able to see me again now. Hopefully. YouTube seems to think you can. I don't know. Yeah, meow. Yeah, the cats want their breakfast. And my stepson's walking around, so they're hassling him for his food. Right. And I'm dropping frames still. Oh, because I'm dropping my speed down. Hold on. Let me do that. That might help. Well, I'm doing ultra low latency this time instead of. Normally I just do the previous streams. I think I did the last one low latency as well. I normally use low latency settings. 3 settings. You got normal latency, low latency, and ultra low latency. So the low latency is about a 20-30 second delay between the time that I'm speaking and you get to see it. And the last stream I did ultra low latency and I thought I'd just give it a go, which means it's more real time between what you guys are saying and what I'm reading and stuff like that, right? So it's a bit more interactive in that way. So last time I did ultra low latency, and this time I'm doing ultra low latency as well. And I'm just trying these things out because it means a bit more interaction between me and you, during the chat, because it's a bit more real time, which makes it a little bit better, I think. But if it's going to be causing problems with the stream, then maybe I won't use that in future. Hey Ian, how's it going? Kami, Robert, Auto 360. Well, but then yours has dropped down to 360. It's probably your connection to the internet or something. Just try going manually higher if you want. Yeah, so hopefully it behaves now. So I'll drop down my bitrate a bit. It's the cat's fault. Yeah, it's always the cat's fault. Those dastardly cats. You have to watch out for them. Alright. 720 settings stopped. Okay, cool. There is still a bit of a buffering delay there as well, but I'm still dropping some frames. Now the problem is because it's a long weekend here, right? Obviously, well, I think it is worldwide, no, because Easter. I'm still dropping frames. There's more people in my area because I live in a bit of a, I don't know, semi-holiday town, I suppose. So lots of people come down here for holidays, long weekends, and I'm going to drop this setting down some more. And I think there's more people on the internet right now, which is going to potentially cause more problems with the stream. So I'm just going to keep dropping these speeds down until it stabilises, and hopefully it helps things a little bit. What are you talking about, Chris? Dog's eating a chicken. Oh, it's very messy. Oh, yeah. I don't do that sort of stuff. I don't do icky things. Oh dear. That doesn't sound like much fun. When will we clean that up? Right. So now the I thought I'd wear a different shirt today. Always a capacitor. After last week, would have been more appropriate last week. This is a shirt I wanted to find last week. Or was it the reefer one? That's the reefer shirt I was wanted to find last week. I'm not sure what it is actually. I think I've lost it. I haven't seen it for a little while. Oh, I don't know. Oh, chicken's okay, it's blooded. Oh, right. It survived. Well, they're not very smart animals, are they? They probably doesn't realise it's been bitten. Probably thinks it fell over something. I've had chickens in the past, not very smart animals. Anyway. Good for eggs, that's about it. Yeah. Anyway, so I'm thinking about what we can do today. So I've got all this, as I was saying before the stream thing and what have you. The gateway which I built, which had blown up, I've got all the bits over there on the desk there because I had to rebuild it. It took me a while because I had to strip it all out and try and find out which parts had blown up. It turned out everything had blown up. And what had happened, I've got a little buck converter in there. There's little modules you can buy from AliExpress. And they've been fine normally, but for some reason when I turn the power on, the inrush current must have blown it. What am I working on today? Well, we've got I'm thinking about using that calibrator actually, that Datron 4700. I'm thinking about pulling that thing apart. There's modules, the buck converter, I think it shoved the full voltage straight through. So normally it drops down to 5 volts. And this runs on a 24 volt system, and normally my batteries are sitting around sort of 27, 28 volts because of solar power generation and that sort of stuff. And so I believe it shoved the full 28 volts straight through to the 5 volt rail, and it blew everything. It cost me about $80 in parts to rebuild it. Luckily, when I designed it, I put most of it as basically plug-in modules, and so the only thing I had to desolder was the actual buck regulator. So yeah, I'm tempted to have a look at those today and just there's not really much to show, but I'll show you what blew up. Actually, I'll do that. I'm still dropping frames. Let's drop this down some more. And I rebooted my internet and everything today as well. Let's see if that's going to stabilise. Rebooted my, because I'm on wireless internet connection here. So I rebooted the antenna, which has got its own little controller stuff built into it, and also rebooted the modem. I'm still dropping frames. I don't need fighting this today. Right. Let's chop it down some more, and so hopefully that stabilises it. Right. I like to have a decent frame rate, but I can't do it if it's not going to be stable. We'll see how that goes. Right, so let's go to the desk, and you can see the module collection just there. So those little bits that blew up. Oh, I've got this bloody flickering going on. Hold on a minute. Let's get this bloody camera set up. I wish these cameras would remember the settings. I should do this. Hold on. Yeah, that's that one. Let's change the other one. Bloody things. Wish I'd remember 50 Hz setting. It's annoying. Anyway. Let's get some more lights on. Where's your eyes? So this little beastie here is what went wrong. I hope you can see the. If I get the thing to focus on it. Come on, you bug. That's what I hate about these bloody webcams. They don't focus where you want them to focus. Look, I'm covering everything apart from the disc. Come on. What's it focusing on now? Still focusing on the disc, even though you can't see the disc. There we go. See that chunk out of it? So that blew up. All I did is turn the power on, it blew up. That blew, and the first thing I actually saw was on the ESP32, which I just dropped. Yeah, let's try and be clever about this. Alright. Going to focus on this? Yes, it is. So the voltage regulator on the ESP32 there, you probably just see it's looking a bit unhealthy. Maybe you can see it. That was the first thing I saw smoking, was that. So that had blown up, and then we got the display that had blown up, a little voltage regulator on the back of there. I tacked on a replacement regulator. That's what the board is, just there. I tacked that board on to see if I could recover the display, and that didn't work. Display is dead. Backlight still works, but the actual driver's dead. There's no display on it. And I've got these two lower modules. These are blown up. These smell quite bad. You actually smell like they're burnt. So, yeah, it costs a bit of money. You know, that's what's that thing, about $20. This display's about $20. In here, about $20 as well. Actually. It's about $5. So, you know, I've lost, you know, a fair bit of money's worth plus the time. It took me a few hours to rebuild it all and try and test everything. Bit annoying, but yeah. It's a shame, because otherwise, apart from that display is a good one. So, kind of annoying. So what I've actually done, obviously this part of this is my own fault for not putting in any kind of over voltage protection in the failure, or in the event of one of these things failing. So, because I just assumed, it was a badly thing to do, is that this wouldn't fail in that catastrophic way. I got caught out by that. So I've now modified the circuitry a little bit to try and protect it slightly more. So what I've done is I've strapped a 5.6 volt Zener diode across the output of the buck regulator. So if it does go above that voltage, it should clamp it and hopefully cause a current surge, which will then hopefully blow the fuse which is before the regulator. If it ever happens again. What's the chip number? That's a good question. Actually, let's set my microscope up, shall we? You can see what I'm talking about. Should we do that? Let's do that. Hold on. Give me a second. I'll change camera views in a second as well. Just let me get this set up. hopefully I can do this. There's that. And let's plug the feed in from the camera. And then if I go over to HDMI, you should be able to see the feed. You should be able to see the feed. Or is it? Hold on. Why is that not working? This should be working. Hold on, let me just get this feed sorted out. What do I have two video capture devices here? That's weird. Is it one covering the other one? No? That's weird. Why have I got two of them? Hold on a second. What's going on here? There's webcams, that's not right. Why isn't it seeing it? I've got the HDMI input running. Why can't it see it? That's weird. Let's plug in somewhere else. No? That one? No? There we go. Right, got you back now. There it is. Why is it like that? What's going on with this thing? Hold on. This is all a bit weird. Sorry guys, this is just... I don't know why it's playing up like this. Okay. Oh, stop being a pain. It's like the view's slightly off as well. What's going on with this thing? Okay, that's strange why it's got the top and bottom cut off like that. Anyway. Right, lots of chat going on. Been missing lots of it. Right, so we now have a camera, so let's show you this stuff. So that is where, I haven't cleaned any of this up obviously, that's where that regulator was on this LCD board. Actually you want two inputs, don't you? You want webcam in this one so you can see two views. Hold on, we want that one. Kind of. Maybe that a bit bigger. See, snapping to the corner of that one you want it to, anyway. There you go, let's do that. Still got audio? Yes, I have, cool. Right. So, yeah, that's what that regulator was, and this is the regulator tapped on, which is a 3.3 volt regulator, which is a AMS 1117. Right, still boards and... Anyway, so that's strapped on there, but that didn't work. Over here we have, let's get this a bit higher, get a bigger field of view. So there's USB 32, and there's a regulator on there, which also isn't looking too happy. It's an AMS 1117 as well, the same regulator as on that board. So that's blown up. So I don't know if it's actually cascaded right through and blown this whole device, I'm not sure. Hopefully it stopped at the regulator, but I doubt it. I thought these regulators could take that kind of voltage though, so I'm quite surprised by that. Yeah. I don't know, I have to look up specs, see AMS 1117, see what the maximum input voltage is for those things. And here's the actual regulator blue. This little bugger. And the chip, something JM97HS, was LM2596S. So, yes, LM2596S. That's the regulator, well, the bucket board, so that went pop. I don't know why. It just did. I'm guessing it's an inrush current thing. It didn't like the inrush, because as I flicked the switch to turn the power onto it, that's when it went. So that's all I can really assume it is an inrush problem. So, I mean, there's nothing around which looks bad. I don't know if that dial is blown. Could have done. But, yeah, I mean, there's not much else to go on here, really, so there's nothing really to go wrong. So, I think those look alright in there, is it? Yeah. So, that popped. That could be anything that's going on with that board. But it's concerning, because, you know, I can't be able to rely on these modules. I'm going to be able to turn the thing on and not have it blow up. So that's somewhat of a worry, because I've got several units which are using this particular module. Maybe I was unlucky with this particular one, I don't know, but I've been using this one before, so this has been used a fair bit, several hours, you know, powered up several times and that sort of stuff, you know, well, dozens of times, and yeah, it's decided to fail. Bit disappointing, but yeah, that's blown up this and this. This is a E32 module. I'm actually tempted to pull the covers off these and see if I can see what's going on with them. I'm not sure how they're attached. I'm guessing it's soldered on. Might be 4 points solder, same as it was on this side. Just like that. So it might be the same here. Looks like it. Or is that soldered through? It might be a through hole. Yeah, actually it's a through hole. So I'll take one of these covers off and have a look at that. But yeah, it's a real shame. There's a further away view from that one. It's a bit less zoomed in. Might be a bit better. But yeah. Anyway, I must say, I might take one of those covers off and see if we can see anything blown up inside here. Just to see what we can get. Let's do that. Then I'll check the chat after we get this cover off. Not sure how I'm going to get it off, but we'll try. Might have more heat than that actually. And more air. Of course, it's got a massive ground plate on it. I've lifted slightly, but I've probably just pushed it down again by putting it down. Let me grab this stuff on there. Oh, well. This isn't working. Should I do destructive methods? It was lifting slightly. It's getting so bloody hot, I can't move it. Can't touch it. Now I'm shoving my fine tweezers into a gap. Sure, that's good for them. Oh, come on. Nah, I'll use the destructive method. Once it cools down. I'll put it back on this and I'll burn the bench. I'll come with the chat. Right. Max is 18 volts. Okay, thanks for that. Yeah. So yeah, definitely will be able to take the 28. And you're doing 2596 is 40. That's what I thought. I thought it was about at least 35. So I'm surprised it blew. It must have been some kind of inrush problem or something. I'm not sure. It's just weird because it certainly isn't that high. Maybe this was a weak one. Maybe it's a slightly faulty unit. I mean, it was from AliExpress. Maybe they are seconds or something. Who knows? Yeah. So I think that voltage went right through the whole bloody lot. Right. Let's do a destructive method. I very much doubt I can fix this. Very much doubt it. I don't know what's inside these things actually. I guess we're just about to find out. I just broke a few parts off. Okay, it's broken anyway. So we got in here SX1276. Let's get a bit of lighting. There we go. Resonator there, what that is? 2D80. Well, there's what's gone wrong, look at that. Look at that part, there it is. Can't really make out the numbers on that. But yeah, there's the problem. Yeah. There's a part which I just broke off and I was trying to chisel the board off. Could have got inductors there as well. There's a chip there. YP2233W. There was some stuff up there, but there's not anymore. Yeah, oh well, it's a shame, but there you go, you can always get the numbers of that. P1 something. Let's get the numbers of it. Is that 9, you reckon? S, P1S. I. Something P1SI. Yeah, anyway. You go bang. It's a shame. There's quite a lot of technology in these things. So we got RF path comes through here, through that inductor, or that could be filtering. That'd be filtering across the path. So it must be coming through this way from here, I expect. So it could be running that way. Is that just me chiseling the gap. Let's just have a look at this. That's like rough opening method. So yeah, there's nothing there. So the path goes through here, around there, through there. So that's an amplifier IC. That's filtering. Come through this path here, most likely. Looks like it from that device. Interesting how this is what does most of it. So it's curious what this is doing. What's a YP2233W? Who wants to look that up? There's more filtering over here as well. Can you see the traces? Curious. Maybe that's some kind of amplifier. There's all those traces here on one side. Not that many connections here, so maybe it's some kind of amplifier. This is a 1 watt module, so maybe it does have. Maybe this is the 1 watt amplifier here, and that's like a preamplifier. It's possible, but this SX1276 is what I believe does the whole lot. Unless that's just doing the encoding. I don't know. Anyway, I thought it'd be interesting to look at. I'm not going to decap the ESP32. As far as I know, that might be fixable. I might be able to replace that and have it work. I will try that, just in case, but rather than throwing away $20. Back to chat. Simon, how's it going? Right. So it's a bit of a shame those things blew up, but hey, stuff happens. You know, it's disappointing. You didn't know about Simon Spears' channel? Simon Spears is someone I actually knew Simon before I knew Chris. I think it was a Marconi 2305, was it? I think it was. It's like a combined modulation and Fuchs account, I think. He was working on one. It wasn't long after I started my channel when I actually, because I had one as well which I'd be fixing. I think he commented on my video or something like that, and I found his video because he did one on it as well at some point. And I did several repairs of mine. I had to repair the OCXO because that was dead. Managed to get that fixed, and I cut other faults on it as well. And so I talked with Simon about that. And sent him some information as well, like video, I did some little videos to show him what mine was doing, to help him work on his. So, used to be, yeah, I was a very early subscriber on his channel. Yeah, I think he had 1,000 subs when I found him. I think it was. I had, I think about 80 or so when I first found Simon. I think I had about 80 subscribers. And Simon had about 1,000. I think it's up to about 6,000 now. I think, I'm not sure. I think something like that. And it's through Simon that I found Chris, because Simon mentioned Chris a few times. So it's a small little community, really. Anyway, yeah, Simon does a lot of interesting stuff. He gets a bit of varied range there too, you know. He likes working on his old radios, like commercial broadcast receivers, you know, the old ones, you know, the old from the 50s and 60s and stuff. That's what he likes to do videos on. But he does some test gear stuff too. I think I've got a link to my channel. If you look at my main page on my channel, I'm pretty sure I've got a link there to Simon's channel on there. Just like I've got one to Chris as well. Pretty sure I've got a link there. I did have one. Hopefully it's still there. Now I've said that. It is a small world, indeed it is. Right, so like I said before, I'm thinking about working on my Datron calibrator or the Datron multimeter. Now the thing is, I'd like to get rid of the multimeter. I'd like to get that fixed up and finished with and done. I haven't done any video on it yet at all, I don't think. No, I haven't got anything in store for that one, so we could do the multimeter, which I think is not really that broken. I think it just really needs recapping, which is a bit boring for a live stream. So I'm thinking about that just as a fact that I want to get rid of it. But there's also, mind you, that said, I've got two of them for sale existingly. I've got the LS101, which I did, the very first one I did, one of the very first ones I did, the LS101. I've got that for sale, and I've also got another 1062 for sale. So, and they're not selling, which is annoying, especially as they're half the price as they are on eBay, but they're still not selling. So I've got three of these Datrons now, which I'm going to be trying to get rid of. You know, New Zealand want one? Anyway, the this one I've got to fix it. Obviously, I've only got two available right now, but once this one's fixed, it'll be three. Or I've also got the Datron 4700 to work on. Now, obviously, last week when we did the live stream, we were working on that HP 8165A. Most of you, I expect, would have seen the video which I published on that on Friday for me. So a couple of days ago. So I expect most of you have seen that, which is obviously the video I recorded at the time and afterwards when I was poking through in a bit more detail and I had to focus on what I was doing a bit more. And so I'm waiting for parts for that unit. That's what I was trying to get to, that one. So my attention went off. So I'm waiting for parts for that before I can finish that. I'll be doing a second video on that one. Unfortunately, nothing's arrived in time. I was hoping to get parts in time for today, so I could do the video on fixing it today. So, unfortunately not. Maybe next week. So I look at the calibrator, because that I've had sitting here now for, God, at least a month. I kind of want to get it working. So I'm tempted to pull that out and start going through that, although that is a massive job. I'm sure I'm going to have to replace every single tantalum capacitor in that thing. Actually reminds me, I'm not sure all the tantalums arrived that I've ordered. I'm not sure they have. They might have done. Have to see. Anyway, catch up, chat. That's right, Chris. We do try and help each other out where we can. I mean, the electronic YouTubers aren't that, well, one that do repair stuff like we do. There's not that many of us. So, and it's, if we help each other out a little bit where we can, it's helpful. It helps the whole community out, because we do have a small niche, and the more we can publicise each other, the better. Do the calibrator, yeah. Indeed, we'll do the calibrator. I think the multimeter is going a bit boring because it's capacitor replacement, but the calibrator, we've got the diagnostics on, we've got to try and figure out why it doesn't work. Whereas the multimeter does seem to be working, it's just noisy. I think I've got all the capacitors, I'm not sure. I ordered a whole bunch of them because someone on the EV blog forum had done a service on these things and replaced the caps in theirs, and they listed the capacitors they used. And so from that list, I bought a whole bunch of capacitors. And I also had a skim through the circuit diagrams as well, just to see what I could find. So, electrolytics, I'm not sure yet. I was only looking at tantalums because well, tantalums are what tends to fail on these things because they've not been rated with a big enough window. So tantalums should be rated ideally 3 times the voltage to be a big safe window between the operating voltage and their rated voltage. So if there's any voltage spike, something like that, doesn't destroy them, it makes it life a bit easier and they last. Sometimes they're only 2 times the voltage, which is getting to a borderline. I think these are even closer than that in some cases. So yeah, I think that's why they're failing. Any bit of noise on the power supplies, and it goes to the tantalums, and the tantalums have to deal with it. And yeah, then it gets too much for them, and they blow. So I just think the window wasn't big enough for them. Yeah, serial generators. That's took me ages to edit that video because I'd what did I have? An hour, 40 minutes of video, which I edited down to, what was it, 45 minutes, something like that. I think I edited it down to. I cut a lot out. Yeah, that's right. It's the ripple that kills the tantalums. That's right. So the tantalums are they're smoothing capacitors. They're not tolerant of too much noise. So any kind of spikes, stuff like that, they don't like too much. That's what they're meant to do, is smooth things out, but they're not that tolerant of stuff. They're really for because they're super low ECR and stuff like that, so they respond very quickly, much more quickly than that electrolytic cap does. So electrolytic cap does the same sort of thing, but it's slower to react, whereas tantalums are quicker to react, so which is why tantalums are used. But you also need the electrolytics in there to get the main smoothing right before the tantalums do their job. But if the electrolytics are gone, tantalums try and do the whole lot, and they don't like it. Hey Kim, how's it going? So yes, we'll play with the calibrator. We'll get that thing on. I'll try and get a thing on the bench. It weighs 35 kilos. High frequency, yes, that's right. Yeah, they work better on faster responses. So yeah, we'll play with that. We'll see what we get. What I might just do is pull cards out and look at cards and do some inspections, see what we can find. If we find anything, we'll fix it just visually, and then I think I'll look at the power supply because I'm sure the power supply is bad. We'll get that out, and daggum, that was annoying. We'll get that out and recap the power supply because I'm pretty sure that's going to need doing. Because if tantalums are failing, there's good chances because the power supply is weak. So I'll pull that out, recap that, I think, and then we could try powering it up. I have had it under power, and I did do some preliminary testing, and I found there were some things that weren't working. So I know it definitely has faults. It's whether or not solving these problems will sort that out. But I believe it's probably power supply problems. It could have caused by other issues though. Could be shorted out supply. So we'll get the thing on the bench and we'll start strip. I'll show us that on the floor. I shall lay it on the floor, pull cards out, and put the cards on the bench. Otherwise, I'm not going to have room because it's big and it's heavy. I mean, there it is sitting there. All right, so yeah, 35 kilos of goodness. Okay, Chris, thanks for dropping by. So let's get this thing pulled apart. Let's clear the desk off again. Get this other stuff out of the way. Give me a second. Shall I do a desk cam view so you can see me cleaning up? Because it's super exciting watching someone clean up, isn't it? Yeah. Unplug the HDMI. Actually, I might want that with respect to the cards, eh? Actually. Or shall I use my camera? Oh. Actually, yes, I might leave this here because I want to use that to show you the cards. I could use my camera to do the same thing, but it's not quite as detailed. But then this might be too close, so I will leave it on for the time being, just to show this at the back like that. Just do that. Let's get this thing pulled apart. Can I show you that? Probably not too easily. Although I should do a video intro and stuff on this, shouldn't I, for my main channel. For the main video, so the actual repair video, I should do something on that. Yeah, okay, let me just readjust. I need to start with that unit. I need to record video at the same time. I was going to forget to do that and I won't have video footage, which I need for the channel. So, let's move stuff around. It's a bit dusty, it's been sitting here for a while. Let's brush the dust off, hold on. Make it look a bit better. That's marginally better. I've already done a couple of little things on this, which I'll explain in a second. Oh my god, that's heavy. 35 kilos. Wow, that's hard on the back. Yeah, still a lot of dust on there. Shove it sideways. This is going to kind of work. More lights. So I need to record some video on this, but I can't see what I'm doing because I don't have it plugged in. Hold on. Alright. Try and get the focusing bit right. So on the bench I've got my Datron 4700 multi-purpose calibrator, and this I picked up about a month or so ago, and it doesn't work. It's got some faults. Well, I powered it up once and had to play with it to see what it actually does, and it definitely has some faults. So we're going to pull this thing apart, inspect all the cards, check all those out, and see what we can actually find, because something's going to be wrong with it, obviously, because some of the outputs don't work. So I already had a sneak peek in this a little while ago, and I do know that all the cards are in here. So at least that part's okay. So it's just a case of being a fault on the card. So we're going to try and dig into this. I expect this to be a multi-part video. I expect there to be lots of videos on this particular unit because there's so much to look at on this thing. There's many cards in here. And it's going to be a long process repairing it all because it's got loads of tantalum capacitors in here. Tantalums are known to be being bad in these. So tantalums are known for being bad in these things. So it's likely that that's going to be the problem. And I'm going to need to do something about that, which is going to be a case of replacing all the tantalum capacitors, and that's going to take a long time because lots of them. So expect a multi-part video on this one, so make sure you subscribe and click the bell icon if you're not already subscribed to catch the videos on this thing, because there's going to be quite a few and I reckon it's going to be interesting. It'd be great to get this thing going. Right. Trust my phone to go at the time. Let's chat the chat. Dave, yeah, they're very sitting in the background there. It's fine. I've just see the top of it sitting there. So I've replaced my small one with the big one, the one which arrived. So I straightened it all out, made sure the earth terminal was well attached and that sort of stuff, and it's fine. Nothing wrong with it. It's just a bit of casing damage because it's so heavy. Its own weight is what damaged it within the packaging. So because it's obviously been dropped or thrown around or something, as the postal system does. Tape on here, I hate that. People have to put tape on everything. Right. So that's the intro done for that. So I think I should pull this apart a bit on the bench and show the inside for the camera. So my video recording is okay. Try and get the focusing set up again. Let's move the camera slightly. Going to move my camera back a little bit actually. No, it's close enough. Right. Where's my screwdriver? So see what I have. Yeah, it's working fine. So it all seems alright. I just had to straighten it all out. So now I've got the 2 kVA one up there, although Chinese rating, it's more likely 1 kVA, which is why I got a big one, because I want to make sure it's not going to burn up like the other one was. So I've got to get these screws out the side. It's got 3 screws down each side, which is like all countersunk in hex ones. Quite nice screws. Like I said, I already had this thing open once, so I've got an idea of what I'm dealing with anyway. But there's still a lot to check, a lot of work to do on this, which is great. It's exactly what I like. I like projects to get my teeth stuck into. The only problem is with this is that it weighs 35 kilos and it's a bit of a pain to move around and work on, which is why I'm going to be pulling this thing off the bench once I've got the thing opened up and show you that part. And we're going to pull the cards out and do the cards individually on the bench. But I just want to show you what the inside looks like first. Let's try and get this open. Something I did on this before. Oh, sorry, there's one more on the front here. This caught me out last time too. There's 4 screws down the sides. So what I've already done here is the rack mount parts here. So these were originally a nice hard right angle and sharp, and these are all bent, these rack mounts. And I actually ripped one of my pairs of trousers on them as I was picking up. It dug into my trousers, ripped them. That annoyed me because they've got nice trousers, those ones. I quite like them. Anyway, the well, shorts, they were a pair of shorts. So I've now rounded all these corners off, straightened all this out, so these rack mounts are now nice and straight, and the radius, so don't catch on anything. There's that problem gone. So this has to all come out. Someone has already been in here at some stage, and they actually marked all these screws already to show which ones to pull out, which I thought was quite nice and helpful. I don't think that one there had to come out though. That one didn't have to come out. I think that was a mistake. But all the ones down the sides have to come out, and those ones which are circled have to come out. So I'm going to get that done. So for you guys, the sticker here is marked as 16th of the 6th, 1988. I'm guessing that's when it was built. Lots of screws. And these other ones here are round-headed, and they've got washers on them as well, so I have to be careful about those. But it's nice, got some of the basic calibration stuff you can do through the top cover. There's a few calibration points you can get to. Not many, just a few. I think actually when I pulled this apart the first time I found one of the screws in the wrong place. Yes, it appeared to be. Try and be careful not to drop the washers through the slots because that'd be bad. Then you've got to go hunting for the things. So I think that one there wasn't required. No, I'm wrong. That is required. Okay, get that one out as well then. Here's the inside of the beast. Right, and there's the inside. It's taken the top cover off, and that's what it looks like in there. It is absolutely crammed. This is why it weighs 35 kilos. Very robustly built. So this is all power supply section here, and that's output section over here. And obviously these are all the control cards for various functions. There's a lot to it. Interestingly, there's a switch over here, 50 volts or 400 volts. I don't know what that's for yet. I haven't read it in manual. I haven't actually read the manual. I probably should do, but I'm not going to do that today. Now, there's a few other little switches around. There's a switch over here as well, and there's a few dip switches I did see somewhere. Thought I saw some dip switches somewhere. This card here has got a stack of reefer caps on it. Now, I'm only going to worry about those if it's high voltage. These aren't high voltage positions. Hopefully it doesn't actually matter that there's reefer caps in here. Otherwise I'm going to have to replace them all. We'll get to that anyway, we'll do these cards. But yeah, there's loads of caps in here. There's loads of big caps right down the bottom here on the bottom on the main board, which you have to take the bottom cover off to get to. So yeah, it's a bit torrid over here. And these cards they'll just drop in, which is nice. Got the upper section over here. Some big heat sink stuff in there. I haven't pulled that apart yet. All I've done so far is I've pulled the top cover off and had a look inside it and pulled cards out and looked at quickly some of these cards. I did find I fault one of the cards, which we'll get to. Yeah, and obviously the main power supply's over here, which I'm definitely have to pull out and check all the capacitors on that, make sure that's working correctly. And there's lots of things I'm going to have to do. There's power supplies and check ripple on and that sort of stuff, but I'm going to pull the cards out first, inspect all those, fix anything we find on the cards, and yeah, we'll go through that and recap the power supply over here to get that part done, I think, and then I'll try powering it up again, because there's big caps down there, there's big ones, big bulk caps which are down here. They generally don't go that bad, so even if I do start to fail, they'll still be doing something. So they're generally pretty good, those big ones. So I don't think replacing those is particularly urgent. I will probably still do it if they're measuring badly, but I don't think they're going to be particularly urgent. It's more likely to be the smaller caps which are in the power supply over here. Yeah, anyway, lots to do. Like I said, multi-part video. Come chat. What, you eat hot cross buns warm? Yes, of course you eat them warm. That's why they're called hot cross buns. It's supposed to be hot. Oh, this be a called a cross bun. I know you're making me hungry, guys. Oh, damn it. I don't know. Right. So let's get this thing back on the floor. And I'll start pulling cards out of it. And we'll just work front to back and we'll go through them. there's already, I can see tantalums here already. This one's got quite a few tantalums on that card. I'm not going to replace tantalums yet, or should I? Is that loose? No, I don't think it is. How many tantalums on that card? It's probably about 8 to 10 tantalums on that card. Probably 10. And a battery. There's a battery on that board as well. Now I'm debating if I should do repairs or what's the word I'm looking for? Come on, guys. What am I looking for? The word is renovation. That's the word I'm looking for. Renovation. Restoration. That's the word. Restoration. Bloody hell. There's no switch over here as well. I need to make note of these switch positions in case I knock them or something. Alright, let's get this on the floor. I'll pull this card out and we'll look at the cards each in turn, fix anything we find, and then I'll do restoration as I require it. Yeah. Okay. I need to get myself some space so I can move again. So like I said, this thing weighs a ton. Well, that's slightly heavy now, taking some of the covers off. Well, slightly lighter now, taking some covers off. Makes more sense than that, lighter. Right. 35 kilos, always fun picking up 35 kilos. So I put a handle on the side. Let's get the first card out. Try and get the stuff so it's not blocking your view. I'm sure you don't want stuff blocking the view, do you? Now, I could use a microscope to look at this, but then you won't be able to see much because it's all just chipped anyway, so it's a bit close for this. I could plug the camera in. Well, I've got the camera already plugged in. I suppose I could feed that one to you. Might be able to see that a bit better, actually. Yeah, but then if the camera turns off, you lose the feed. I don't know. Always more fun when you drop on your foot. It's not much fun. I've done that before. Tantrums, yeah. Hey Johnny, how's it going? Yeah, they're all colour coded so you don't get them messed up. Do you like it when I do that? Well, the only problem is the actual tabs are colour coded, but there's no slot colour coding. So the slots themselves don't have any colour coding on them, which things like HP tend to do. They have the actual slot itself will have a colour on the HP gear, whereas this doesn't have that. It's just a plain slot. So you have to still make sure you get the colours in the right places. And nowhere do I see any labelling saying what they are. I'm presuming the cards are in the right places, but I think they've actually got different connectors in a lot of these cards as well. The actual connector layout's different as well, in different places. I don't think they're all the same, which I think helps that. Right. Try and get this camera better. Right, so here's the first card, and it's upside down. As Dave will say, the electron's going to fall out. So you can see here we've got several tantalums on here. There's loads of them scattered around. So this is a little bit of a time involvement to get those changed, but they all need doing. And also got a battery on here as well, which is a lithium cell. And I'm just looking to see if I can see anything blown or damaged. I've already had a look over this card originally when I first got it. I didn't notice anything then, but that doesn't mean I didn't miss something. So no harm having a bit of an extra look. And have a look on the back of the board. See if there's anything on the sign, any signs on the back of it to say anything's been replaced. Now there is a bit of flux residue up here. What's that? That's that button up there. There's a push button. I'm not touching that button. That might wipe the calibrations or something. Who knows? If I put this thing face down, if I put this card face down, it's going to press on that button. Now, what does that button do? Does that wipe the calibrations? I don't want to recalibrate it if I don't have to. I'm hoping just fixing it will be enough. Anyway, as I don't actually have much in the way of good references, I'm trying to do calibrations with a bit of a nightmare as well. So I don't want to push that button. So let's measure this battery, make sure the battery looks okay. But visually this card looks okay apart from the fact it's got a bunch of tantalums on it which have to go. Oh, what's that? There's a little bit of black plastic that was on my finger. Where does that come from? Oh, that's one of those little tabs. Compression tabs. So somewhere there's a little push tab which is broken off. Do I have something here to show you? No, I don't. Interesting. Was that already on my desk or did I pick it up from first thing? Ah, there we go. This one here is broken. Or is it? Oh no. No, it's not broken, it's just half. It only does half the hole. Okay, so that's not broken, that's fine. But this looks like one of those little push tabs. You've got those little plunger thing, like I've got in the Datron 1062 multimeters. On the one I hold the balls in, you've got those little push tabs, you pull them up. I forgot what they're called now, you've got a certain name. I did actually find a source for those, so I bought a bunch of them, so I'm not too worried about those being broken and throwing, because I have spares. Alright, let's check this battery, see what's going on here. Right, let's go there to there. 3.7 volts, obviously I've got it backwards. Yeah, I'll do it right around. So 3.7, that looks fine. That's not looking like it's got an issue. I'm looking at it thinking it's been replaced already. I think it probably has been replaced already, but there's no date on it, unfortunately. It's called an AA size. It's a TL5104. That's what it's marked as. But it's an AA size, which is fine. Yeah, that's alright. I've got loads of these cells now. I've got a bunch of these cells. When I did the 1062s, I bought a selection, but they're smaller ones, not as big as this one. This should last longer. Also got the EPROMs on here. The date codes on these are 1988, 19th for the 4th, 88. So it's 290141-4-2 and 290140, 290139 and 290138. So backing those up might be an idea. There's also potentially a PROM over here because it's got 290122-1 marked on it. So that's probably a programmable device as well. Likely to be some kind of PROM. Anyway, you have to be careful what you do on these boards because if there's RAM, which there will be, you could lose the calibration constants if you're not careful. So I'm not going to put anything unless I need to. EPROMs will be safe, but other than that, got to be careful. So I think that board's looking alright. I'm just going to slot this one back in again. Or should I check for shorts across tantalums? Let's check for shorts across tantalums. just in case there's a power supply rail fault. Yeah, seems alright there. Just check some random ones. Yeah, there's no direct shorts, so they're looking alright. Let's put that back in. Chit chat. Tell the battery says the button doesn't work. Yeah, thanks, Johnny. No, the other Datron had lithium cells in there by default, not NiCads, because they're a long-term backup battery rather than just like a last use setting storage thing like the HP was. We worked on last time. So the HP was it's just for local settings, you know, the last use settings you use, and it wasn't too critical if it goes flat after a year. Which is calibration constant, so it's a bit different. So they stored them in lithium cell, which has extremely long life, and you know, there's still the ones I've done so far. I think I've only had one which was flat when I did the multimeters. The others have still been going fine. I've still replaced them anyway because I've got some. They're not cheap to buy either. I think they're about $20 a battery, or something like $25 a battery. They're not cheap, but if you're done to lose your calibration constants, you need to replace them. Right, let's check this card out. So here's the next card. Thankfully there's tantalums on here. There's one over there, one there, one there, one there. And the rest are all ceramics of some kind, dip ceramics, or monolithics. So not too bad for tantalums on this board. Look on the back, see if there's anything on the back which shows up as being reworked. It's always a clue about its history. That looks factory, there's no signs of any rework at all on the back of that board, which is great. So, it makes you tend to replace the tantalums on this board and mark this one as done. No, I won't. I'll just do those separately. So, I'll put this board back and look at the next one. So here's the third board. Now this one's a bit more interesting, there's a bit more going on in this one. So we've got, I don't know, a dozen tantalums on here as well. There's a switch which is in position number 2, making like that. Obviously the board's upside down right now. There's a few links and stuff for doing test points, I'm guessing. I think this is the voltage reference board. We have some reefer caps. So 6 reefers. No, sorry, 8 reefers. No, more than that. There's more underneath there. Oh, I don't know. I think we've got about 9 reefers in there actually. So if I see any cracks, I'll be concerned about replacing them. If you see cracks, then yeah, you got to replace them. But these are looking good. I don't see any cracks on these. I guess it's because they don't have the same stresses applied because they're not on the main 240 volt system. So they can stay as they are. I don't have a problem with them if they're in that kind of situation. Like in the Datron 1062 multimeters, they've got a reefer on the analog board on that thing. And it's the same as these. It looks fine. So I don't have any problems with these. These are all 0.47s, looks of it. All of them are 0.47. So yeah, there's some tantalums around. I don't see anything blown. Still looking. Check if any burnt resistors, that kind of thing. We've got these two ones here which are, I don't know if they're slightly discoloured or not. There might be a bit of band markings. They could be discoloured. Let's have a close look at those. If I can find them again. Lost them, yeah. So just here and just here, the ones I'm looking at, I'm trying to determine if they're discoloured or if it's the band markings. There's another one there. I think it's the band markings. I think there's a black band in there on the brown, which makes it look like it's burnt. I think that's what it is. I don't think there's actually a problem with those. Yeah, I'm pretty sure that's right. So I want to have my camera right next to me so I can zoom the camera in and look at my monitor, which is over here, and I can get a much closer view than I can see with my eyes. It's quite handy for that. So, right, let's look at the back of the board. Interestingly, we've got a tantalum tacked on the back with hot glue, and it looks like a little bit of flux residue around here. That's on the back of that switch again, so probably nothing. There's a bit of flux over here, a little bit there. Might be nothing. That's by those through-hole pins for the PCB, and that's a resistor leg, which this side looks fine, I think. There's a bit of flux residue of this side as well. I wonder if that one's been touched up by someone at some point. Just a little dot. It's almost nothing. And over here's a bit of flux residue just there as well, a tiny little bit, and a bit up here and there. I think someone's been doing some touch-ups on this thing. Yeah, there's not much, so there's nothing really stands out. It's like an IC being replaced and all that. But this tantalum being on the back of the board is interesting. I wonder if that's a factory modification. It's got some hot glue holding it down. I was trying to pinpoint exactly what's going on there. It's on the IC here, it's the MC14001UBCP 4001. What the hell is that thing? That is a NOR gate, isn't it? Yeah, quad NOR gate. Surprisingly, that on there. Anyway, a bit more interest in this card, a bit more going on, a bit more to look at. Right, but nothing obviously wrong, which is a good thing, I suppose. Next board. Check the jet. Let's move the microscope out of the way. Hey Grant, sorry, I just got your message here. Thanks for that. Appreciate the offer. Let's make a note of that. Who knows what you find these days? Magic smoke generator board. No, I hope not. That board, Grant, is from a Datron 4700 Calibrator. Oh, Dave just answered that for me too. Yeah, I do tend to light boards up from the rear if I need to, in order to see traces. It's a very handy way of doing things. What I've actually used in the past is my studio light, so I'll show you this. So there's my studio light there, which I use my main lighting. Obviously got other lighting as well on the desk. But what I can do with this thing is I can tip it backwards, and what I've actually done in the past is I put a board on this light, tipped it backwards and used that to shine light through. So I've actually, then I can actually see through the boards. So I've done that in the past myself. It's a very handy little trick. Right, back to the desk. Which board do you want to see close up? The last one or the one I've just put on the desk? I can get your one back out again. It's not exactly much hassle. Silver cylinders, though, will be precision resistors, most likely. There you go. Don't know if it will focus on it because, you know, the camera's awesome like that. But yeah, these will be precision resistors. I'm pretty sure this is resistance board. Pretty sure. Right. So here you are, next board. So these look like precision resistors to me. I could be wrong, but I think that's what they are. The manual will obviously tell you what board this is and what they do. Now, one thing I do see on here is a jumper plug, which is here. It's on pin 1 and 2, if the board's out the other way. It's on that side. There's another couple of jumper plugs around here as well, so these may be options or calibration settings of some kind. Not quite sure. It looks like it's falling off actually. Let's just put that back on properly. No, it doesn't want to move, if it's alright. So we've got a few electrolytics around the place. There are some tantalums as well. Again, I'm just looking for anything that could be burnt, any bad resistors, blown tantalums, that kind of thing. Because I'm expecting to find blown tantalums. I did find one when I did my preliminary check, but we'll get to that. Not on this board, on a different board. But there could be other things which I missed, which I said before. Those few jumper links, a whole bunch of relays. It could even be bad relays, you never know. Relays not switching over. They don't work forever. It's got a precision resistor here as well. I think these are precision resistors, pretty sure. I don't see anything bad on that side. Flip it over. Yeah, okay. So that tantalum I think you saw on the other board, that looked like potentially a factory bodge, and these are done exactly the same way. So I believe these are all factory bodges. They may even be revision changes. Now sometimes they revise the board and they change the board slightly over time, and it could be these are changes after they've originally manufactured it, and so they do later revision, they'll be retrofitted modifications. But on this board I'm seeing a lot more flux residue, so I'm seeing some down here, some up here, a bit there. So that's on a diode. What's up here? That's on a, I'm not sure, capacitor to transistor junction. some up here, which is on a capacitor. Now there's some here and here and here. Now I think those look like they're very similar footprints. What's that like? Okay, so these look like transistors, but they've only got 2 legs. So I'm not quite sure what those will be. That might require more investigation, but all 4 of those have got solder residue on them. This IC here has got solder residue. 8746. Looks like it's the original part though, so maybe it's just been touched up. So nothing really stands out. I mean, obviously that's been resoldered, which is interesting. So that may be a sign of a problem in the past. But nothing really that bad. As that's an original date code, it's probably fine. So, did I forget to record that? No, the camera's not running. Let's record this bit again, just in case I forgot. So this board here looks fine. I've checked both sides of it already. There is some signs of rework on the back. Here by this IC, over here, a bit there, a little bit down here. It's not too bad though. These modifications are like the factory, so that looks fine. I think it's alright. Check again. Hey, thanks Grant for the donation, much appreciated. Twice no less. Thank you very much. According to schematic, big red button goes to microprocessor and triggers a restart. Okay, thanks for that, Johnny. The issue with the unit is that it doesn't work properly. I've had a bit of a preliminary check around it, and basically DC volts, AC volts don't work properly, things like that. I didn't have it powered up a long time because I didn't know what sort of condition it's really in. I asked a preliminary check. Yeah, Dave did get a whole bunch of solar panels. Lucky bastard. I'd love to do solar. Anyway, let's get on him. So he got really into it. It looked like I think he did a tweet this morning, something like, saying it's got some weird consumption issues going on with it though. So I think it's got potentially one of the sensors backwards or something. The actual current sensing on one of the panels is probably backwards. It looks that way anyway, but anyway. So it's got a little issue there to get sorted out, but otherwise I think it's pretty good. Alright. Next one. Make sure I'm recording this time. Here we go. So, next board. And this has got quite a bit going on this one. Got some local regulation looks for it over here, potentially. I've got no idea what this board is. I'm not going to worry about what they actually do at this stage. I'm going to figure that out in time. But right now it's doing just a generic check around to see what I can find. As I said. So there's loads of tantalums on this one. There's probably a dozen. Maybe more. It's a few polyester or polystyrene caps. Not too bad. So I'll be recapping this whole thing anyway. I've got to do all the tantalum caps, all the electrolytic caps. as a matter of course, because I don't want to be messing around with this thing, and you know, the caps might, even if you measure them now and test them, they come out okay. In a year's time it could fail because it's only borderline now. So I do tend to just do a blanket replacement. Anything I want to keep and it's worth investing the time and money into, I will just do it. I'm not going to mess around scrimping on it. I'm just going to do it. You know, what's $20 worth of capacitors or $50 worth of capacitors on something which is worth $10,000? You know, it's just not worth it. Just do it. Because these things are retailing for like 10 grand working on eBay. I've got this thing, I think it cost me about 4,000, I think it was, 4,000 or 5,000 by the time I finished paying all the shipping and all the fees and import duties, stuff like that. It cost me about 5 grand, I think it was in the end, for a non-working unit. So, yeah, I'm motivated to get it working, obviously, because I've invested an awful lot of money in this. I'm not going to be scrimping on $20 worth of caps, or you know, whatever it would be. I think I spent about $200 worth of caps, actually. Just on tantalums, I think I would have spent $200 buying parts. So, yeah. Anyway, it looks okay. There's no signs of rework on the back of the board. Another little factory bodge over there, but nothing really there shows up. This board looks fine. Apart from having a bunch of tantalums on it. There's nothing that stands out anyway. Just double check in case I missed anything, but I think it's good. We'll go to the next board. Chit chat. Oh yeah, the power supply is almost guaranteed to be bad. Oh yeah, live stream. So is Brian Locke. I know he was going to live stream as well at the same time as I started. So there's a few of us live streaming at the same time, which is a bit unfortunate. Say hello to Clive for me. I mean, I drop in there from time to time. You say Defpom says hi, you know what you mean. Okay, thanks Grant. Thanks for dropping by. And thanks for the donations. Right. The next board. Quite a few relays on this one. Wow, there's a bit going on this one as well. But usual thing, we'll look see if anything's bad. There's less tantalums on this one, which is good. That's 4 here in a group, 5. Well, that's probably 10 tantalums that I can see straight out. So not too bad, but oh, there's some under there too. So there's probably a dozen tents. So that cover will have to come off. I'll have to get underneath here and replace those as well. Some plug-in module over here. Precision resistors. Here we go. So that's obviously a little resistor reference board under there. And there's a couple of jumper plugs around, so that's on the pin 1 and 2 over here. Top 2 pins on that one. But again, nothing really stands out as being bad. Which is great. I mean, I don't want to find a whole bunch of blown components in every board. I've been through that scenario with the Fluke 5200A calibrator, which had every single board had a fault. That was why it's a 19-part video series. So the back of the board here has got some rework over here by what's presumably an op-amp. It's a circular footprint, so that's one of these metal can ones. There's a little bit of rework over here, a couple of spots which look like, oh, a fuse. So fuses over here, there's a fuse over here, and there's something else here. Is that a diode? Or resistor? I think it might be a resistor. Yeah, it's higher up, so that's a resistor over there. Let's check this fuse since I just found a fuse. Let's see if it actually works. You never know. Could be a clue. Yeah, that fuse is good. Alright. Anything else? Looking pretty good. Now really while I'm handling these boards, I'm touching the boards, and I probably shouldn't really be doing that. I should be using gloves to keep my oils off the boards. But as I'm going to have to do recapping on these things anyway, I'm going to be handling them and all sorts, so I'm going to have to clean the boards afterwards anyway. So really shouldn't be handling precision boards without gloves on, but they need to clean afterwards anyway, so it's not really going to matter that much. That one's good, put that back. We're dropping lots of frames, dropped over 5,000 frames. Let's drop the setting back slightly more. Just a little bit, just like another 100. It's looking okay right now, but I'll give it a bit of a headroom. Right, so the next board. So here's the next board. This has got a bit going on this one too. Got a 4-wire resistor right here. Bunch of relays. Some precision resistors over here as well. 99.980K. So sometimes they'll do resistors which are positive and negative coefficients. So what it means is if you've got a resistor which is if you get a temperature increase, resistance might increase, which is typically how resistors work. But you can also get resistors which go the opposite direction. So therefore, if you get a temperature increase, resistance decreases. And what I do is I get two of the same value and put them back to back. So one will offset the other one. So if one goes up, one goes down, and it helps to give you the average of the two, which means you've got a more stable reference. That's one of the tricks they use, especially like the Fluke does that quite a lot. The 54 50A. Which I've got there, they do that in there. Back-to-back resistors, different coefficients. Aha, here we go. Here's the blown tantalum, right there. Right, we found something. And there's a bunch of fuses over here as well. So I'll just check all those. We'll check on the back. No signs of rework. That looks perfect on the back. So we'll check these fuses and we'll replace this tantalum. We'll have to find out what that is. But we'll do that now. Since we actually found a fault, I want to resolve it. Check fuses first. Fine. Fine. Those fuses will check out good. Also got a catalytic resistor over here. There's definitely a resistance board, or at least one of them. Don't see any more fuses around, so I think that's it. So I need to replace that tantalum and find out what the hell that is. So I need to find out what this board is and what that tantalum is supposed to be, and we'll replace it right now. And I'll show you guys this blown tantalum. Actually, I'll record it too. Get a close shot. So there's the tantalum. As you can see, it's blown apart. The top of it's completely gone. It's black. Usually what happens is you get a big crusty mess. Just a lump of carbon. This is actually blowing the top of it off. Don't know if I can get the focus on it, can I? Usual trouble. There you go, blown tantalum. Right. Let's find the manual and find out what that tantalum is supposed to be. Manuals, Datron, 4700. I've got a few manuals here. With schematics. This is a 40 megabyte manual. Let's see if I can find the right page. Right, first thing is just figure out which card that is. And let's try and find where that is. There's only pages in this, 594 pages. Right. Where does it say about which one's which? I was getting error 5, was it? Error 2? I think it's getting something like that anyway. Section 4. Yeah. Dismantling, yeah, might need that. Well, let's go find it. This could take a bit. So I need to find a diagram which shows the card layout, which is probably in the servicing section somewhere. I didn't see it listed as that in that index. Somebody can find it faster and tell me what it is, that'd be great. Wait for it to catch up. There you go. Halfway there. Right. Oh, what was that? Was that it? So this board is the current and ohms assembly. So 11.8, is that the page we need to go to? Looks like it. Okay. Or at least the diagram we'll go to. Let's try and find that. All these out of sequence, they could be out of sequence, that'd be annoying. I think they're doing multiple diagrams for each board. Five, no, keep going. What was that? Is that it? No, 11.6. See it somewhere. 11.2. I must have gone past it. Hold on. Where the hell is it? What does it look like? It's not that one. Let's look for a physical board layout and see if I can find what matches. It's not that one either. These are replacement sections, there must be. That's the other board. Not that one. Not that one. Not that one. Where is it? Not that one. Maybe it's not in that bit. Maybe I've gone past. I hate trying to find things like this. Once I find it, I'll make a note of where the board is, but I've gone past it. I must have done. We're right back to the beginning now. Okay. let's go past that bit then. Yeah, there's more there. Here we go. All right. There's more. Okay. Let's keep going. I thought I'd got to the end. Come on. Who is it? 11.8. Is that 11.8? No. What is it? Yes, this is the board layer here. Okay, found it. Page 376. Don't forget that number. So we're looking at capacitors over here, which looks like, is that C36? Yes, it is. C36 is blown. Right, just find C36. Hopefully. This is going to be fun. Yes. Okay. B for babies, yeah, well, to a point. I don't have a power box, no, I don't. I used to have one, but I never used it, so I had the thing for about 5 years and never received a single piece of mail. Didn't seem like a worthwhile thing in the end. Right, C36, let's try and find that on this less than perfect diagram. I did find a partial manual. I'm trying to find the second part actually. Annoyingly, I've missed out on that one. It was listed previously, I missed it. Just bad timing. So we've got to try and find C36 somewhere. And this isn't the best bloody layout either. Yeah, not the best. Is that 50 or 30? Is that 31? Is that 32 or 52? Yeah, trying to find it's going to be fun, but if you found a better diagram, that'd be great. Like I said, they've got separate pages. They do each section as another diagram, so yeah. It's 18. $24. Next page. It'd be somewhere else so I can read it, that's all. This is relay switching stuff, so I don't think it'd be in this bit. It's a subboard. So it won't be in here, I think. This is now a different board. Awesome. Back we go. It must be on that first page somewhere. Let's start from here and go backwards. This is C33. Let's get close. The 24, 33. Zoom in too much. Back out slightly. Held you. Well, there we go. I think I found it. C36, 22 microfarad, 25 volt. 25 volt. That's across a 15 volt rail. Yeah, that's not enough margin. Definitely not. That's less than 2 times. That's why they're blowing up. So you've got 37, which is the other one, which is also across a minus 15 volt rail. So I should probably replace that pair. And I'm done with that pump. Okay, Grant. Lots of caps, eh? Components and stuff. Great. Yeah, remember to like. Definitely do it. Everyone like the video now. Do like. I found the capacitor. You should like it for that. So 20 microfarad, 25 volts. Yeah. No, okay. So I think I've got 35s, or was it more than that? I've purchased. I might be 50s even. I have to see what I've got. Yeah. So 22 microfarads. Let's swap those in. Do that. And I'll change the camera view so you can see what I'm doing. How's that sound? In fact, I might even do that one. What do you reckon? Is it shorted? I should check that before I pull it out, shouldn't I? Good point, Dave. But likely it will be. It could have blown itself open. Measuring 3.3K, so it's blown itself open. Now I'm getting high resistance. So, 43K, yeah. So it has blown, it's blown itself clear. So it won't be causing an existing fault right now, so there's probably other stuff going on as well. Let's get some soldering stuff turned on and working. So I just measured the resistance across this capacitor, which is blown as suggested by one of the people in chat. Thank you, Dave. And I'm getting currently 3.3. Keeps on changing. So that capacitor is blown out, but it's blown itself clear. But it's also scarred the one next to it. Those are both 25 volt capacitors, and they're on a 15 volt rail. So the tolerance is nowhere near big enough. Now, as there aren't that many capacitors on this board, I'm just looking to see if I find the others which I've missed. There probably are some tucked away. Yeah, there are a few. Only this little can here with cover. So what I'm actually thinking about doing, I might replace all the tantalums on this board and just do this one board. And then I'll come up, this board is done, and not have to revisit this one again. Electrolytics, I don't see any on here. So I think it's just tantalums on here. Using a lot of ceramics and stuff like that in monolithics, which means you don't have to worry about them. I can see at least two or three tantalums underneath this panel here. I have to figure out how to get that off. Probably take it off from this side and be really careful about these wires and not pulling them. Although it's got a plug on it, so that could be handy. Might be able to unplug it. Yes, I can. I can just unplug that board. So we'll take this off. Then we'll start looking on replacing the tantalums on this board, and hopefully I've got all the ones I need. I hope so. over here. Grab that plate so it doesn't fall off. Now this should, I think, just unplug by the looks of it. Might require a little bit of extra effort. Some clips in here. Okay. So that's just some resistors on the heatsink. Nice. So there's 4 tantalums underneath there. So we've got to do 5, 6, 7, 8, 9, 10, 11. 11 is what I'm seeing here. Unless I'm missing something. Thankfully I should be able to read most of them rather than having to look them up in a diagram, because that's a bit of a pain trying to find the things. But these two here I know are both 22 microfarad. 22 microfarad tantalum, not electrolytic. There. And I've got cables and stuff in there. Let's move some stuff out of the way. Did my bag videos yesterday, so I've got stuff lying around. So what we got here, these are what I purchased the other day. That's 33s, and I should have 22s in there as well. 22s, 35 volt. So that's those ones there. We'll put those in those. They're somewhat bigger, but that's fine. I think I'll get those two done, then I'll start from this side and work that way. So polarities, I have to pay attention to that as well, don't I? Which way around did they go? That's the next question. So, okay, there's 2 legs here which are joined together. Let's try and get some camera and focused. So before I pull these things out, I need to check polarities. So they've got a junction together. See, the bottom leg of that one goes to the top leg of that one. So that means that is a 0 volt common there. So one is the negative rail, one's positive rail. And I think this is the negative rail, that's the positive one. So I'll have to make sure I put those face to face, then those will be the correct polarities. Pretty sure face to face is right. No, it's back to back. Okay. I'll get that right to put them back to back, not face to face. That's negative rail, it's positive rail. Right, now I've lost where they are. Over here. Shall we call this, or it's going to be noisy? Actually, I'll put fresh solder in first, it makes it easier. So I'm going to put some fresh solder on these first to help get them off. It makes the job a bit easier. I'll tell them where they are again, because I keep forgetting where they are. Over here. I've got the wrong soldering on tip on there. I've got a massive one on here. I need to change that. Not really suitable for this particular job. Want the next size down, which which is this one here. Alright, so let's desolder these things. One, two, and put new ones in, back to back. But really, the reason these things are failing is because when Datron designed this, they didn't allow enough tolerance on the tantalum capacitors. I mean, they're below the ratings, but the ratings need to be exceeded by quite a bit in order to be safe with these things now. It's a bit fluxy, that solder. Let's use a different one. I'll use my silver solder for this. I should turn my extractor fan on, but it gets a bit noisy. Do have an open window anyway. Alright, where's the tweezers? Here we go. Tweezers, cutters. There. Turn those there. Okay, so that's two done. But yeah, I'm going to have to repeat the whole process for the whole board. So I'm not going to record the whole thing. But that's two of them done, which I know are definitely going to be bougie. I mean, if they're not on a main rail, if they're on like a 5-volt rail, it probably wouldn't matter if it's only on a 5-volt rail, because the tolerance is so great, it should be fine. But when you've got something which is this expensive, it's worth spending the money and just replacing them regardless. Right, check, check. Yeah, RS started charging. Yeah, I noticed that. I bought some stuff from them the other day, and suddenly I was getting charges. Like, wow, that's annoying. Because I'd actually choose RS over them at 14 because of the postage costs, right? Because I could get stuff for, I could get $20 worth of stuff, not worry about having to pay postage, or $50 worth of stuff, and not have to worry about it. Whereas now they're charging for anything less than $70, at least New Zealand dollars, that is. So, yeah. Is that what it was? Change of courier company. So I use RS and Element 14 and sometimes Arrow. Arrow is really good. I've actually used Arrow a few times now. I've been really happy with them. So I'm likely to use them more. It depends on postages and stuff like that and what I actually need and how quickly I need it. Although that said, Arrow is often faster than RS or Element 14. They're all much for muchness, really. I think it's now going to come down to postage costs, but like I said, I was using Element 14 for stuff over $70, and I was using RS for less than that, unless I couldn't get it, whatever. But now RS is the same as Element 14, so often Element 14 is cheaper until you factor in the postage costs. Alright, so I think I'm going to be buying more stuff in Element 14 now. I really have had issues. I haven't received the item I purchased yet. What did I buy? It's the stuff for the HP, for the 8165. The read relays, I'm waiting for those. And something else. There's a couple of things I'm waiting for. Bulbs, that's right, bulbs and read relays, I'm waiting for those. Ordered some from both companies. There's some different options. So a bunch of them, so I've stocked up on read relays. I spent like $200 on read relays, as I tend to do. I'll get ridiculous buying extras. So purchased a couple of different types. So next time I've got the parts I need in stock, as is the way. So, right, that's those 2 caps done. Let's do the rest of the caps, and hopefully I can read the values off them. Okay. Is this view okay for you guys, or do you need something better? Oh, leaded solder thing, yeah. Just get it from LM14. RS would not sell me a leaded solder, so I did some videos on it. I don't know, a year ago now probably. I did some videos on that, and Final refuses your access. That's interesting. But yeah, I purchased lead solder from Element 14, and I bought a bunch of it. I've got. Shall I show you up there? On top of those cabinets up there, those sets of drawers on the wall. Up there, I've got about I don't know, 5 rolls, something like that. I've got loads of it. Yeah, 60/40. Also got the other one, which is 60. Was it 38? So what is it? 60. Whatever my leaded, my solder, whatever my silver solder is, that's also leaded solder as well. Jaycar has it, but the quality is not as good as the Jaycar one. I don't like that one as much. I've got some from Jaycar. It's okay, but I prefer the multi-core myself. I just find it works slightly better. The Fluxus seems to suit what I do. But yeah, it should be able to get from overseas. Like I think Arrow sells leaded solder. Jamaico, I don't know. Jamaico Electronics. That's another site. I haven't ordered from them for years. Actually, I used to use them. I don't know if they've got it. That's another one to consider. Yeah, so you should be able to find it and get it somehow. Just don't get it from RS because they won't let you, unless you're a company. If you're a company, they let you do it, I think. Yeah, I think you have to be a company, not an individual, because companies have to adhere to safety standards. Individuals don't, so therefore they'll sell it to companies. Oh, it's too expensive, yeah. Oh, it is expensive, a lot of stuff. But sometimes, with, say, as I was saying before, with the shipping costs, even though the parts and stuff are more expensive than, say, from Element 14 by comparison, because of the postage being free, you could get a better deal with RS, even though the parts may be more expensive. Depending on what you need, obviously. But, yeah. So I'm going to have to reconsider how I buy things now, because RS will be my go-to place as the first spot because of the postage costs. And now, if I'm spending less than $70, Ultronics. Okay, you sold from Ultronics. I'm not familiar with that one. I should look at it, actually. I think you might have mentioned it before, actually. I haven't been there, I don't think. Maybe once. Discounts, breaks in quantity, yeah. Sometimes you can only buy things in quantity too. It's the other problem. Is like there's been times I wanted some parts, not in capacitors, but they only sell you 50 of them or 100, and I want sizable camps. So you'd be talking like $300 or $400 worth of parts, and I only want 5. No, or 5 or 10. I usually buy sort of 10 sort of thing if I can, depending on cost. But yeah, there's been times like that where I haven't been able to get it from there because the price was wrong and the quantity was too restrictive. Yes, I use a lot of capacitors, but I don't use that many. I want them to not be expired by the time I go to use them. Anyway, right, back to the bench, just to carry on with replacing caps. Actually, before I do that, hold on a second. just reminding my wife what time it is. I said to her, bring me if she could bring me something at 10 o'clock. It's now 10:15. Right. Now we go back to bench. And we'll go back to that view. Those reels of 1,000, yeah. I don't mind buying 1,000, we're going to use them. Alright, so I've done those two. So the next one is over here. I don't want to pull it out unless I actually know what I'm dealing with first. I might have to get the microscope out to see these. Yeah, this is a little bit trickier. That's okay. Where is it? There it is. You guys can't see this, fortunately, because I've got my cable plugged into my camera now. That is a, I don't know, it's 35 volts, 1 microfarad. Okay, I'm sure I've got some of those. Yes, I've got a drawer full of them. Don't go to sleep, I'm going to use you in a second. Alright. So this one over here is a 1 microfarad. Let's get it on camera here. So let's look at my microscope over here, and this capacitor right here is 1 microfarad, so I'll replace that one. I'm just going to work across the board and see what we get. I can smell something. I can smell food. I think my wife's making hot cross buns. That could be what the delay is. I just got a whiff of it. I think she's already onto it. I think my request for assistance was unnecessary. But wife's very good like that. I'm quite lucky. Even put solder on the right part. Make sure the solder as well. That one. No, that seems right. So there's a 1. Replace that with the 1. Cramped over here. Problem having half-done projects, so I have too much stuff going on. Put this over here, I'm using that again right now. So, what voltage is this one? This is another 35 volt. I'm pretty sure it's a 1, not a 10. It's a lot bigger. Yeah, it's a 1 microphone. Okay. Of course, I have to make sure I put all these in the crypt polarity, don't I, as well? Because it'd be a bit inconvenient if I do that and get it wrong. I think this iron might be a bit hot. Don't want to risk burning the board. Come here. A little bit. These older boards don't like to have too much heat put onto them. Newer boards are a bit more tolerant. I don't need to put a huge amount of heat on, so just dropped it down slightly. I'm not going to clean this up until I've finished. So that's that one. We've got another one over here. What's this one? laying flat the wrong way around. And where are we? Come on, get on the microscope. Let's say 10 microfarad. So we'll sort that one out. It's right here. Tens. Let's see. As far as you look at these in the microscope, they're looking by hand. Anyway, 10 there. But yes, it's going to be quite a long, tedious process, I think, doing this whole bloody conversion, refurbishment. Yeah, I just want to be sure it's all good. I'll probably replace stuff I don't need to replace, but I don't want to take any risks. Ooh, snacks and drinks.
Hot cross buns. Happy Easter.
Yeah. I might take a break. Then you guys get to sit there watching me eat cross bun. I'm not quite sure about that though. Take this back a little bit. So that's that one done. Next one's over here. Try and see what they are. Here. That's a 2.2 and the one next to it. It's also a 2.2. Great. So only two 2.2s. This is why I keep a stock of parts, because you know you can just grab them out. They're right there. You know, if I was trying to do this by ordering parts, I'd be here forever. Yes. Let's find those bloody things over here somewhere. Find those pads. Right there. The reason I put a fresh solder on just helps them to desolder. It just freshens up, makes them work a bit better. I'll place these two, then I'll have my snack. So some of these parts are probably absolutely fine, but I'm not going to take the risk. Go on. There's some solder blobs on the other side, I think. Okay, I went flying off somewhere. I don't know where it's gone. I'll find it next year. Make sure I get the right ones. 2.2. Oh, that's rated 25 volts. Yeah. What else have we got here? Do have some 35s. For 35s. Yeah, these are 35s. Get them off the tape. Obviously, always check polarity. Tantalums, in particular, do not like being wired up backwards. They're almost as bad as it is Rutix. And they go pop! And if these bits flying everywhere. Yeah, anyway, get those in there. I'll check the chat whilst I'm having my lunch. Got my snack. I don't know, it's not really breakfast. Oh, is it breakfast? Because I haven't eaten yet, so I suppose it is breakfast, isn't it? Now my habit is always to cut the leads off straight away, because there was one time when I was doing some work on something, I can't remember what it was. It wasn't a big test kit or something else. And I'd forgotten to unclip the leads, or cut the leads off. And also, as I was putting it backwards and forwards, it folded the leads over, and it shorted against the other things on the board, and I powered up without realising, and that was bad. So now I make a point of clipping the leads off first, even though it's less efficient time-wise. Just better practice. Okay, let's catch up to chat. My lovely wife's bought me a drink. Hot cross bun, yes. Hot cross bun. Now it's warm cross bun, because it's been sitting here for a little while. Blow one up on stream for science. Hey Mako, how's it going? Yes. Oh yes, barely warm now. I left it too long. Component holding sponge. Oh yeah. I know some people use things like blue tack. It would be handy sometimes. I know there's been times it's been a pain flipping things over. Things like this, so I just bend the component leads. It's fine. I'm sure you guys don't really want to sort of watch me eating, do you? Yeah, let's change. Let's go back to the desk and you admire the desk. There you go. Nice messy desk. Or we could go to the you always look at the circuit diagram. That's strange. Just try just a screen only, without me in the corner of it. Thought I had one just top screen only. Anyway. Yeah. So I wonder if those ones I just replaced. I wonder what they are. Probably on a 5-volt rail. Who knows? There's even a 5-volt rail on there. Is that 15 there? Minus 15 there. 0 volts. It's only plus a minus 15 volt rails there. And we've got this power arrangement. So looks like everything's running 15 volts. So yeah, replacing everything's a good idea. Andrew, here's a game. I don't use any kind of adhesive on the SMD stuff. Ian, you're still there. You're very quiet. Guess you was running in the background, have you? Yeah, I don't use anything else. I just use solder paste or even normal solder, SMD stuff. That's it. I don't do anything else. That's past midnight where you are, Mickey. Yeah. What country are you in again? I've forgotten. Sweden, was it? Or somewhere in there? I've forgotten where you are now. Good question, Helmut. Good question. No. But there are multiple sheets. Netherlands, that's right. There's another diagram here, so there's multiple sheets of the same thing. You can see this one. Camera's turned off. I have to make sure I turn it back on again so you can see what I'm doing when I'm doing the other stuff. So it's minus 15 volt rails. Oh, great. Idiots in town. Come with holidays, get the organizers down. Must have a small deck, that one. It's plus 22 volts mentioned over here. It looks like it's running a plus or minus 15 volts, the whole thing. So all over C mentioned is plus or minus 15, so yeah, just like replacing all the tantalums is important because otherwise they're only 25 volt rated. No, it's a car. No, it's some Mitsubishi thing, I think. Oh no. I don't care. It's an idiot. Previous schematic, it appears to bypasses the left side of screen display. Was it this one you talk about? Or something here? As a rated as 35. Did I miss something? I was just out of curiosity anyway. Plus and minus mentioned here again. There's another one here, I think. This is all the actual resistor switching. Yeah. I think that was the last one, it was, yeah. So, I'm sure I'm scrolling up and down for the schematic, doesn't it? We got on the screen for you guys. I don't know. I don't. Anyway, I'm just going to replace everything I see anyway. So physically, I'm just replacing what I see on the board. I'm not too worried about what's on the schematic so much. I just want to I was curious about the voltage ratings. Because if they're running on a 5-volt rail, I probably don't have to worry about replacing that particular one. But it takes me more time to figure out whether that part is on a 5-volt rail than it is to actually replace the part, so I might as well just replace it. So it did mean keep going up. That is now a different board, so it's not that board. So yeah, I don't know what you saw. Obviously I'm not seeing it because I'm probably not looking at the right thing. Okay, so we've replaced C36, C37, C32, C28, C29, C30. Still got the C26 in that group. So we're getting there. Yeah, Johnny, YouTube notifications are weird. I mean, it notifies me that I've gone live. I mean, I know I've gone live. I'm the one that set the thing up and did it. So I don't know why it notifies me. It should be telling everybody else. Anyway, here's people getting out and about. Let's turn the microphone around this way more because it's a directional microphone, so it's away from the window. Ah, okay. Right, now I've got what you mean. So I've got to find the right page. What's this page here? So this one's got the plus and minus rails on it. I've got a whole bunch of relays down here. There's a bunch of relay markers. Is that what you're saying? It might not look the same to you because the resolution's not so good. These are relay coil indicators. Unless I'm missing something else. Or do you mean a different one? Ah, it don't matter. Anyway, we'll get back to it. We'll replace some more. Coffee on. Back to work. We want that one. I need to turn the camera back on. Yeah, Fred, didn't I subscribe to your channel? I think did I subscribe to it? I don't remember. Or did I just look at it? I can't remember now. Alright, so I've got to do this capacitor over here now, which is a 10 microfarad 25 volt. No, I've looked away, I've forgotten where it is. Here it is. So I'm going to solder here. 10 microfarad. Is that a 10? It's actually really handy to have my microfarad set up. It's really handy. Yep. And get that in. The right way around. This has got a square pad denoting the positive side, which is handy. They seem to be keeping the same convention at least. Now, is that bridged or is that supposed to be there? Soldered off the other pad next to it as well. I think it's supposed to be there. Just chuck some flux on it to be sure. Yeah, it's fine. Yeah, that's basically joined together. That's all right. Don't want to risk it. So we've done that much so far. I think we've only got 4 left, is it? I think it is. Guess I'm missing anything else. Yeah, just those 4 left. So let's find out what these things are. So it's a 10 microfarad 25 volt. Well, that's an interesting one. That's a 100 microfarad 6.3 volts. And another 10 microfarad 25. That's interesting. Okay. The middle one here. Let's try and get a shot on this camera so you can see what I'm talking about. So that one there is marked as 100 microfarad 6.3 volts. Curious. So those two there are the 10 microfarads, so we'll get those out. Let's see what that one was. What's that one? That is a 1 microfarad. Right. Having this is really helpful. Should do it more often. So I'm not sure about the 100 microfarad one. I'm not sure if I've got one that big actually. I will have to look. I'm not certain. Where's the other one? Down there. So I'll do the 10 microfarads first, pull those out. So those ones. Oh, that's not the right one. That's the That's not a tantalum, that's something else. Put that back in. They sold the wrong one. This one here I want, that's a tantalum. Right, some tins. Please have a certain level of peace of mind knowing that these have been done. So I've got to do this to every single board, so it's going to take me ages. Which is, not really live stream material to do the whole lot. So I think I'll just, so like I said, I was going to go back to my original plan, which was to check every board, fix anything I find, and then look at the power supply and see what we can do with that. Then if the power supply checks out, then I'll recap it as much as I can. Then we'll try powering it up and see what happens. But I don't want to do that before I've done the power supply, because obviously I might blow up all the caps I just put in, and that wouldn't be good. Alright, so I've got to do, I need a 100 microfarad. Do I have one? I do, but they're a bit big. But they're 10 volt caps. It looks like these might be pulls, which makes me wonder actually a bit about that. I've got a 10 microfarad in there, that's weird. So 100 microfarad, 10 volt, brand new. Let's probably get these other ones. What stores are those? Maybe about salvage them or something. Anyway, we'll chuck this one in. So it's an up spec of the voltage. It's got to be a good thing. Over here, so I can get the caps mixed up. Just double check this voltage, just make sure I didn't misread it or something. Yep, definitely 100 micro, 6.3 volt. That's definitely what it says. Come on. Trying to go older things, the problem. This one's being stubborn to get out. Of course it is. Here we go, it's out. It's on the floor now. Never sit again. Here we go. Read it again because I'm just paranoid about this being the wrong value. Yep, that's definitely what it says. Odd. Alright, let's replace it. least it's definitely been upgraded. 10 volts is a bit better than 6.3, isn't it? And it had enough room for these things, so I don't know why they scrimped on it a little bit. Like that, you know, they had the room to put a bigger one in there. It doesn't stick out too much or anything, so I don't know why they didn't do it. Yeah, it doesn't stick out any more than anything else on the board, so I could have put a bigger one in there. So I think we've only got one left to replace now, and that's that 1 microfarad up just up here. And that's that board done. Come on. I don't like to yank on components because that's a great way of ripping traces up. So I just like to wiggle them because that breaks any residual solder that might still be there. So 1 microfarad for here. You're going to upgrade it as well to a 35. Make sure. Yeah, 1 microfarad 35 volt. Focus is not quite right, is it? Here we go, slightly better. And this board is going to need a good clean because it's resistance board, so it's a precision board. So I need to make sure I get my oils from my fingers off it and all the fluxes and stuff off. Alright. Let's get cleaning after I check the chat. How many boards are on it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 at least. There might be slightly more. Okay, Dave, thanks for dropping by. Catch you later. You like the WD-40 electronic cleaning spray? I haven't tried that one. So I'm going to use alcohol. I mean, I don't know, maybe I should use a proper cleaning spray on this one initially. I do have stuff. It's I've got this electronic cleaning solvent stuff, which is supposed to get flux and stuff off as well. Is that the right one? I've got an assortment. Other than that, I'm going to be using this alcohol as well. I just use alcohol last to get any residues off. Yeah, that's what I've got right now. Yeah. Right. I seem to have 2 cans open for some reason. Cleaning solvent and circuit board cleaner. What's the difference? One says flux. Let's go with that one. Just get some tissue down so it absorbs all the runoff. Right. There's still another sticker here. I want to try and avoid ruining that if I can, anyway. The camera's turned off again. That's convenient. Is that pad solder properly? I've resoldered that one. It's right next to the ones I desoldered. I think I sucked some of the solder off it. This doesn't look quite right. Let's put the bit on. Right. That should at least get rid of some of it. Let's alcohol it. Rather messy, but here we go. Bit of chance to drain off. You see the gunk has come off on here. You see a line. So it's definitely got something off. Let's just leave that draining for a bit. Right. Yeah, we clean the contacts as well. Once it's all run off, I'll run along the edge and clean the gold contacts up. I've got some deoxide gold stuff there, which I'll use for that. But I just want to get the board clean first, then I'll worry about that once it's all run off. You saw that from here, yeah, it's pretty bad and stuff. I've got windows open, so I've got ventilation. So I'm not too worried about that part. Hey, Quadrant 2005. How's it going? Is this the only PCB? No, there's a lot more than that. Did you not? Oh, yes, right, you weren't in here, were you? Let's just get this spun around. To get this one. So, they're just sitting down there. You can see all the boards vertically in there. So, half the unit's for the boards, the other half is, well, 3/4 of the unit's for the boards, really. It's all crammed in there. But this is the one which had the blown tantalum on it. So this one definitely had a failure happen. So, and it's been on the main rail. Yeah, means the power supply for was it the positive rail, wasn't it? Yeah, positive 15-volt rail. Power supply is probably a bit on the dodgy side. But the tolerance, as I said before, 25-volt tantalum on a 15-volt rail, not good. Oh, yeah, you remember some of my stuff, do you? Cool. I don't do much CB stuff these days. It's been a while. I haven't done any real CB stuff for a couple of years, really. I'm doing this test gear stuff and YouTube most of the time these days. .059, the 121s, yeah. I was never really a fan of the Cybernet stuff. Those chassis, I didn't like the circuit boards. They're double-sided boards, which is pretty good at the time. A lot of other radios weren't, but the double-sided boards had problems. They had problems with the wires going through, and you end up with various faults because the connection from one side of the board wasn't making it to the other side of the board. And sometimes it's actually really hard to get to those wires to resolder them and run wires through and stuff like that. Yeah, I've got a bunch of radios. I think I've got about a dozen radios sitting around. I've got a bunch which I need to fix, so I do intend to actually get around to doing that. Like, this is I suppose my main lab where I do my YouTubing and most of my electronics work. But I've got a second lab set up in the other room, and that is dedicated to doing RF stuff basically, which is why I don't spend much time out there because I don't do much RF stuff, ironically, after I set it up. So I've got radios out there which I need to do. I've got various things set up out there. Yeah, 121s. Yeah, I've had to fix a few of them. They're okay. What I didn't like as well is that the AM power output was an issue as well. They didn't like to do as much power as they claimed on AM. They struggled with it because the modulation suffered. Yeah, they claimed it was at 7 watts in some units, but actually, nah, 4 was it. Anyway, because I had the high-low power option on the high, medium, low power setting. Was it on the Superstar 2000, was it? That one? Something like that. Yeah. But yeah, I haven't been approached for doing CB work for a while now. I was doing a bit here from time to time for truckers, mostly doing conversions on Cobra 29s and 148s, that sort of stuff. Radios got in from the US to convert them to Zin channels. But I haven't really done much of that recently. CB's like a dying thing. FM2 wide, yeah, that's right. Yeah. Anyway, just have a close look at this board, see if it looks like it's clean or not. Yeah, ish. It's still got a bit of residue around there. It's not too bad. It's mostly gone. I'm going to see a little bit. Or it's still drying. I might still a little bit more just over here. So at least that's one board done. So I need to find my stickers. Ah, there they are. I've got some stickers which show have a little label on them, so I know when it's been worked on or not. So I can be sure that board's been finished with. I can mark that one. Although it is untested, there could still be faults on the board, possible, but visually it looks okay at this stage. I mean, I'm hoping it's just power supply problems. It could be a bad power supply which has then blown a fuse. No, but that could have blown and then blown the fuse for a 15-volt rail. Who knows? Could be something like that. But all the fuses I've tested so far have been alright. Mind you, there's an inductor here in series, L2. 10 microhenry inductor. So I should probably check that, because that could have acted like a fuse. So L2, we need to find L2. Just to be sure that's okay. L2 is right here. Okay, you can't see what I'm pointing at because I haven't got the thing on the right screen. So L2 is right there, just below that capacitor we replaced. Well, the C36 was blown, so L2 is right next to it, so I need to check, well I must check them both I suppose, make sure they're okay. K148 GTL DX Mark II. Oh, yeah. Is that one of the original ones? The 3-band one? In a box? Refurbish it, recap it, then sell it. Oh, someone will power it up and blow the crap out of it. I used to have one of those. I did a modification for that. I did an EEPROM modification with a mate of mine many years ago. It's one of the first, actually the very first EEPROM modification I did. Was it a Superstar 360? I mean Superstar 360, but it's basically the same thing. What was the Mark II? I don't know. The Mark II was the PL02A, wasn't it? Oh, that's not bloody hell, PL02A. The MC145-106. The Mark II was MC145-106. Is the Mark I, which had the MB8719. Alright. It's looking pretty good there now. Alright. It's I'll flip this over. Check that, and you won't be able to see what I'm doing because I haven't changed the camera around. But I'm sure you can imagine me testing a component couple. Good. Just let me do around so I can see it. Yeah, it's fine. Both inductors are fine. No problems there. But it's nice to know for sure they're okay. So I think I can put this board back together now. Let's change views. And where's the mouse gone? There it is. That one. Sure, let's do this one. This is the one for now. Get the camera on, hope it doesn't stop. Alright, so there's the board. All the tantalums have been replaced now. I can put the little daughter assembly here back onto the board now. I've cleaned it with some circuit board cleaner and some IPA to try and get any residues off, because it's a precision board, so anything like that, because I've been touching it all over the place with no gloves on, it could affect the leakage across the board, so I've had to clean it. Hopefully it's cleaned well enough. Does still appear to be a little bit of residue in some spots around here, but I think it might still be drying, I'm not sure. Or it's still running off. Might need to give that area here a bit of another go. I'm not sure that's okay. The rest of it over here looks alright. So, anyway, put this back together. Put the plug on. Put the plug on, he says. There you go. Nice and tight, that's good. Put this over here. And we've got to lay this tantalums down because they stick up a little bit. Now, get the screws back in. Where did I put that screwdriver? place but not tightened up. The same other ones. I'm not sure these tantalums are clear of this panel yet. I won't know till I get it mounted up properly. I may need to bend them over. I've bent a couple of them over already, as you saw. Hopefully. Yeah, I've definitely still got some residue around the place. I have to give it a bit more cleaning. Yeah, those two tantalums are in the way. Okay, that's what I thought. Let's give them a shove. Just like that. Make sure to clear the panel. Don't even want them touching it either. Alright. Do some more cleaning around here. It's not quite good enough yet. Because that's where that residue was. Was it this one? Had the board? The op amp had work on it? Was it this one or was it another board? Can't remember now. Anyway. Probably less critical around these digital sections. Most of it's going to be this area, which is the important part, because this is where the resistors are. Alright, we'll leave that to drain off again. Come on, drain it this way. Right. It's really clean, yeah. Did more to cyber it. You asked more of the Uniden guy. I don't know, the Uniden stuff. Nice and tight, not loosey-goosey, yeah. Well, that's the thing, can I... Yeah, I mean, if I had gloves on, it would have been better to avoid residues on the board from my hands. It would have minimised it, as you say. But because I've had to do so much resoldering, I've got the flux residue everywhere, which is going to end up spreading. As even when I clean it, it's going to spread. So I've got to do the whole board anyway. So I just have to make sure they look clean when I finish. So there's no signs of residue on them when I've finished them. So it should be as good as factory. Hopefully. Yeah. Some boards won't really matter, but other ones which have got like resistances on them and things like that, references, then they're going to be quite critical and it's going to be quite important to get those right. I'm still recording. No, I'm not. Okay. I don't know. So yes, that's one board done. I'm going to put my sticker on it. Hopefully that board is actually okay. Yeah. So we've got one more board to inspect in that card arrangement, which has got a lot going on, that one. It's got lots of interconnects and stuff going on. And then we can look at the power supply section. Well, start looking at the power supply section. There's a few bits to it. The one I tried to get out before and it seemed to be getting stuck on something. I couldn't quite get the card out. I need to figure that one out. Yeah, we'll see how we go with that. But that's the one I really need to get out, is that power supply and do all that stuff before I'm willing to power it back up again, because I don't want to potentially cause more damage. Yeah, anyway. Let's have a look at this. Yep, it's looking pretty good there now. It's looking a lot better. So I just want to clean this gold edge connector here as well. I shouldn't really need to, but why not? And I forgot to change the camera around so you can't see what I'm doing. You can just imagine me cleaning these gold edge connectors with a wipe and some alcohol, can't you? They're not looking too bad. There's no real signs of any oxidation on them, so I'm not too worried about that part. Usually you can see like a residue build up, and if that happens then yeah, sure, you need to definitely use some proper clean on them. Alright, now I'm going to try and get the next board out. The next board is involved. Oh, some merch. Yeah, let's try and get this one out. It's got lots of connections on it. It might take me a minute. Also mustn't forget which way around is go. Some of them can only go one way, so it's not a problem, but other ones have got multiple options. I need to get in here with a screwdriver or something to pop that out. Something sharpish. Yeah, spudge will do. It's got a bunch of plugs on it, you see. I've got to get those out. There we go. Starting to pop out now. Pretty tight, which is a good thing. Don't want it to be loose. I've only got one more left. Clean my desk up a little bit. Get rid of this smelly tissue. Right. Change views. Yeah, now you can see what I was doing because it's on the floor. Right. So this one is a bit of a interesting one. I think this is an output board. Okay. So I finished the last board, reassembled it, put it back together, put it back in the unit, cleaned it all obviously, and we'll see how that goes. Now this is the next board, which looks like it's some kind of output board. It's got a couple of electrolytics standing up on here. They might need doing. Which we'll have to see. In fact, there's a good chance I do need doing. But it's interesting, got an axial and like a radial positioning. Weird. So there's electrolytic here, a couple here, although there's no signs of doming there. So I think I should just replace the electrolytics on here. There are a bunch of tantalums on here as well. Quite a few of them, but they look like quite small ones. Like mostly 1 microfarad by the looks of it. Maybe some 10s. I don't see anything bad. Now it's got some interesting bits in here. It's got a couple of what look like neons up here, which are curious. Have to be careful of those, not to damage those. A lot of neons. I'm not quite sure what the stories of those. I'm not seeing any signs of leakage on the caps or anything like that, so they're probably alright. Let's look at the back of the board. No signs of any work being done on it. This area here is darkened, so it's obviously getting hot in this area, which is where that heatsink is from that device. So yeah, heatsinking could be better, I suppose. It's aging the board on it. It's not good for it. That's an BUZ50A. That's on. So it looks okay, apart from the fact it's got some electrolytics on it. So I might just put this one back in again and say, yeah, right. I'm obviously going to revisit this board and replace all the tantalums, replace the electrolytics. Whether they test good or not, I'm going to replace them. But I'm not going to do that right now. It'll take me an hour. So I'm not doing that right now. Any fuses on here? Don't see any fuses or anything, so I'll drop it straight back in and we shall move on. We'll try and get that power supply board out. Although down the bottom here, which you can't see because the camera view and everything, there's a big, a really big capacitor down there. It's just like a some kind of film cap, but it's a massive one with 4 electrolytics next to them. They're on the main motherboard down the bottom there. And there's a little sub PCB here, which I think I shall check. And there's some fuses down here too. I should check these fuses. If I can reach them all. They look a bit awkward. How are you supposed to repair them if you get them if they're right tucked down there? That's interesting. There's another electrolytic stuck down the end as well. So it looks like the main logic board, or the main motherboard of it all, has got a few bits to look at as well. But not too bad. I'm just going to jump in here, although you can't see. I'm going to try and capture it. Change views again. Go to this one. Now, there it is. Yeah, I'm just going to try and get in there and test these fuses. I might have to use the other probes actually. Bit better access. Get you out the meter. Work. Hard to measure the SR, but you can to a degree. It will be different when you take it out. But it can give you an indication. If it's way out of whack, then you know it's definitely wrong. But it won't give you a proper, meaningful reading. Right, let's try and get to these fuses. There's a few of them down here. That was obviously good. That was good. You've got some little mini ones. These are quite big ones, like normal 20mm size. Now some little tiny ones look on the circuit boards. Now I've got to try and get these wires out of the way so I can get to them. You know? Not so easy. That's alright. I'm sure you can see it's top of my head. Yeah, that's alright as well. Okay, so that's 4 fuses down there I could check. There might be more tucked around which I can't see yet. It's possible. We'll see what we get. So I'm going to slot this board back in again with all these connections which have to go back on in the right order. And they're getting hung up as well. Come on. It's got these little heat sinks everywhere, getting stuck on them. Right. Fun. It would be nice if I get this thing on the bench, but it's not possible. Just too damn big. Yeah, there's a little sub borders here. Let's pull this out. I think it'll just pull out. Let's look at this one. Alright. Just change to this one. Is that blue enough for you? So this one's obviously some little output control board or maybe a preamp of some kind. It could be a little sub power supply. Could be. It's got some electrolytics, some tantalums and a couple of TIP 146 or 146 and a 141 just over here. So, right, it's the next board, little sub board. Not much going on here, which is quite nice, but I've still got 4 capacitors which need replacing. It's got a couple of big pass transistors here, but this side looks like it's got nothing of concern. Flip it over, no signs of any rework, so this board's probably never been touched. It's looking okay, but I'm tempted just to replace these parts now. Whilst I'm in here, I'm going to just do this one. So at least then I've got 2 boards, which actually I need to put a stick on that other board, mustn't forget. So I don't forget that I've done that one, hopefully. I doubt I would anyway, but yeah. Let's put this on here. So that's our first of all part is done. So we'll do this one. Not much to replace, so I might as well get it done. So the two electrolytics are 100 volt, 10 microfarad. Let's have I've got some of that value. $100 quite interesting. Oh, there's one. 100 volt, 10 microfarad. One. I've got one, I should have two. Yep, there's another one. So that's fine. Good caps for those at least. I'm not going to bother testing them, I'm just going to change them. They're old. So negative that way. Don't fold it over, it's inconvenient. Come on, Bill. Still seem awfully secure. No, let's do it your way. Alright, pop the new ones in, somewhat smaller. Yeah, don't lose it. So yeah, bit of a size difference here. So I'll just desolder these two caps. I'm going to put the new ones in, same ratings. Although they're physically somewhat smaller. I just wonder if I can actually put a larger value in. Oh, that's not clear. Those in it. Then I did the tantalums because there's only 4 of them. Get those done. Then this board can be marked as finished. I've got so much to do on this unit. The more I can do in one go, the better, I suppose. But equally, I don't want to go diving down rabbit holes, replacing parts if it not necessarily that board's even the problem. But there's this electrolytics on here. Again, yeah, it's worth a look. Although the output board had the electrolytics on it too, but they looked okay. And I decided these ones. But this is a simple one to fix. Simple one to do. So let's replace these. What have we actually got anyway? Let's have a look. We have a 1 microfarad, 35 volt. That might be fine actually, 35 volt. So is that one, and the big ones are 10 microfarad and 10 microfarads. So yep, 2 10 microfarads there. And so I almost were 1. Said 1, didn't I? I need to make sure. Yep, 1. Okay. So 10s and 1s, easy enough. But a 35 volt, so does it really need it? Probably not. No, I tend to leave these ones actually. They're 35 volt rated. Ooh. Do I leave these ones? Actually, I think I might leave those ones. They've got a decent rating, not like borderline, I don't think. Mind you, these are 100 volt rated. Those are rated for 100 volts. Shall we look at this board and find out what it actually is and see what voltages are likely to be here? If it's less than half, I'd probably be okay with it. I might leave them. Let's have a look. Let's find out what this board is. Oh, the time wearing headphones, yeah. So let's find this board. Here it is. So see 6, 7, 8, 9. There's fuses on here. I should check those. Oh, interesting. On the board, those 2 electrolytic solenoids replaced with 100 volts. On the board, it got 63 volt ones on here. That's interesting. Okay, so where are those tantalums? Where are tantalums? I must have missed them. Oh, there we go. So inputs on op amps, so it can't be that high voltage. From those rails, which are from that AC supply, which is God knows. There's a 6.8 volt Zener across here on that section and there. So there's a 2.45 volt Zener across here. So yeah, it's fine. It's only really low voltage. I won't need to change those, they'll be right. At least for C6 and C9. 7 and 8 across the 6.8 volt supply. So those will be fine. And you can see this is like the wrong height, isn't it? That's better. Cut my head off. So yes, the those tantalums across the low voltage power supplies, I'm happy to leave those. They'll be fine. They won't be stressed at all. Anything which would have been spiking would have been clamped onto Zeners anyway. So I'll just check those 2 output fuses. That's fine. It's good. I've got schematics, yeah. Even though they're not the best quality schematics, I've got them. I did try and find the manual. There's a 2-part manual for this thing, service manual. I managed to find volume 1. Volume 2, I saw a listing for it and I did an eBay search, a Google search for it. And volume 2, which is from this set, because it's got the same name across the top of it, had already been sold by someone. It's like, oh, damn, I missed out on the second manual. And the second manual's got one that's got all these diagrams in it. The first part is a lot of circuit description and calibration stuff. And the second manual is all this servicing information. So, It's a shame. That's the one I really need to get. Is volume 2. So yeah. Right, back to the disc. So I'm happy with that one. Then let's go back to. Yeah. So I've looked at the circuit diagrams just now, and those tantalums here on low voltage power supplies. So only like 2 volts or 6 volts, I think it was, or 8 volt supplies, and like that. So these are nowhere near any, being stressed. These should be absolutely fine. So I don't need to replace those. There won't be a problem with them. Electrolytics, yes, I mean they probably will need replacing. Interestingly, on the circuit diagram it said 63 volts, but it had 100 volts installed. So anyway, it's 100 volts again, so it's upgraded, which is fine. Let's give us a clean, get the stuff off here, and I'll put the thing back in again. The connector a bit of a clean as well. It does look a little bit tarnished. On both sides. Yeah, that's better. That's fine. Right. That one's done. Where's my stickers? Now we're going to put the sticker so I can see it's been done. Yeah. Of course, there. How's that work? You reckon that'll do it? What could possibly go wrong? Yeah. At least I know. Done. Put it on back in. So, I'm going to try and get this power supply boards out now. These are going to be fun. Oh, I didn't check the fuses on that board, did I? Where were they? There they are. Check these fuses before I forget. Then I know it's definitely okay. So that will punch himself with it. Yep, sweet. Okay, confident that one's right. Right, let's try and get these power supplies out. This is definitely going to be interesting. Now I'm just wondering what I did with the spudger I had. Oh, there it is. Because I left it in the unit or something. You won't be able to see what I'm doing right now. You have to just wait a second. Or 5. Or something. Come on, let's go. one's a bit tight. Well, these connections are really nice and solid. I've still got to pull two boards out at the same time, because they're kind of interlocking together. That makes things a bit interesting. There's loads of electrolytics on this one, so this is a good prospect for the recapping. That's great. I'll be able to show you once I get these bloody connectors off. Super tight. Right. Here's one power supply board. Let's get the other one out. Here we go. Here's the other one. Bulging cap, slightly bulged. It's also wobbling on the board quite a bit. I think it's extruded slightly. That feels like it's extruded slightly. So it's definitely two bad caps on that board. Definitely. Excellent. I'm going to go for a pee. I'll be right back. Then we can carry on. Entertain yourselves. I'm back. Let's see what we're dealing with here. So here are the two power supply boards which just pulled out. I've had a quick look already, just a really cursory one. These two caps are bulging. This one's bulging quite a bit. That's got a slight bulge in it. And they look like they're extruding slightly. At least these two look like they are. They're standing off the board a little bit. So we've got an issue on here. There's some tantalums, of course. Tantalums over here as well. This one's looking like a simpler board. Let's check these fuses, because it's got a bunch of fuses on here, see if any of those are blown. But we definitely have to do some recapping. There's no doubt about that. Right, fuse here. Looks fine, but that's okay. Fuses here. Good. Good. All good. Okay, so there's no blown fuses. That's actually slightly surprising. There's lots of fuses through this thing. It's quite good in a way. the whole unit's got fuses everywhere, so which is I suppose they're thinking about, doesn't it? So we've got a bunch of 40 volt 1000 microfarad. It looks like that's what they all are, actually. These are 63 volt 470s, both of those. So 2, 4, 6, 7, 1000 microfarads. Got a couple of small ones around the place as well. 1000 microfarads. 16 volt, 25 volt. I don't have enough capacitors to replace all of these. I'm going to have to get some caps in, that's not good. Yeah. I've only got low voltage ones. But if they're in parallel with each other, which is possible, then it might be able, well, I might be able to just there you go. If they're in parallel, then I might be able to just put in a larger value across one hole. For example, take two parts out, put one larger value in one spot instead. So it's the same capacitance. It might be possible. I'm just trying to see with the layers. This is a multi-layer board. Because these two caps are linked together over here, but I can't see the other trace in the top side. There must be a layer noodle. Or it's just hidden, I can't quite see. Oh no, there it is. I can see a trace there now. Now I can see it. Now I said that. Let's get even more light. There's a trace running across between those two. So I'm hoping it's parallel capacitors, which means I can just no, that might be positive and negative supply. Those two might be in parallel. Those two there. There's a trace between those ones. I can't see where it goes. Those two are in parallel as well. So those are in parallel. Those are probably in parallel. Those don't look like they are. So if I've got some 2200s, that'll probably be right. What do we have here? 25 volt. Well, I've got 25 volt caps. These are 40 volt rated. I need to look at the circuit diagrams to figure out what power supplies we're likely to have on these caps, because if they're, I don't like to downgrade a voltage. I'd never like to do that. But as I have a bunch of these, there's a 50 volt one. There's one that'll be alright. Yeah, I've got enough lower voltage ones, but I don't want nice to 16. Yeah, that's not enough either. There's a 25 there, so I do have some 25s. I don't think I've got enough parts. There's a 25, that's two 25s. There's a 16. There's a 16. That is a 25. That's a 16. I might have to buy parts in, please. I haven't got enough to do anyway. What's this big beastie here? 16. No, and it's a used one. I don't want to put a used part in. Well, that's annoying. I haven't got the right parts on it. How does it ever happen? So I've got these axial ones instead. 25 volt. 25 volt, yeah, no, not suitable. So I think I need to look at these and see what I actually need to get. 3300, so I haven't got any of those actually. Axial, so I need to get some of them. the 10 microfarad 350 volt axial. I don't have any of them. So yeah, I'm going to have to get parts for these power supplies. That's irritating. Just when you thought I had bought enough capacitors. 4700 16 volt. Can I do that one? Yeah, I've got a 25 volt one. So yeah, that's fine. I've got some of those. So that's alright. So I can do that one. So I can replace that one. Can't replace those. Can't replace that. Although I might be able to upgrade. I think because these two boards go close together, when they're actually in the casing, they sit like this, basically touching. So they're almost touching. So the height wise, I have to be considerate about. But I think I've got enough clearance on this one. I might be able to upgrade that one to make that one better. So I've got a 15 at 450, although the height's a bit pushing it, I think. Yeah, I think I'll have to get some caps. That's irritating. I so wanted to get this done today. I wanted to do the power supply and power the thing up. That's not going to happen. Damn it. That is so annoying. Well, let's look at the diagrams and see what voltage has got across these supplies and figure out what's going on there. Then we'll go from there. That's irritating. Here's my trusty RAM stick. It's on the desk. It's there. No, I'm not in the UK. I'm in New Zealand, so I'm on the other side of the planet. It'll take, from you, it'll probably take 2 weeks. So, fortunately, not quick. Yeah, when the postal demand isn't too bad, it's a week to week and a half from the UK. Right now, it's at least 2 weeks. So, yeah. Yeah, just try and catch up the chat. Right, I think I'm kind of caught up. Yeah, I've got a UK accent. I'm English. Well, I am formerly English, I suppose. I've got dual nationality, so I'm both. But I've been in New Zealand for 30 years. Thereabouts. Been here longer than I was living in the UK, put that way. So, right. Yeah, I talk fast, I know. The more excited I get, the faster I talk. Or if I'm rushing, like, if I'm trying to get through something quickly, obviously I speed up. And then, yeah, I do get comments on my videos about talking too quickly. But I've always spoken fast like that. Just the way I am. In fact, I think I used to speak faster. I think I did get better, believe it or not. I've already done that YouTube tax thing. I've already done that. Here's what it is. I have to pay taxes now on YouTube stuff for the US. Just another tax. At least I don't have to think about it, it just happens, you know, it's automatic, I don't have to worry about it. That makes it easy, I suppose. But yeah. Right, so I need to order some parts for this thing, which is annoying. But that's okay. I should maybe consider checking other boards out for the other electrolytics I might need to get parts for as well. Or should I just risk it and go, yeah, it's fine. Yeah, the output board, I should look at those electrolytics as well, shouldn't I? Make sure I get those ones in stock. Since there's so many of them on there. Can I replace the worst ones? Well, the thing is, I don't want to risk doing more damage to it. Like if there's, I mean, I could measure them, but the ones that are bulging are definitely dead. So we got, was it 3 that are definitely bulging? Another one I'm a little bit suspicious of, but the fact that they're all exactly the same capacitor, in the same area. They've probably been exposed to the same environment, same kind of heat, because they're right next to heat sinks, which ages capacitors is never good for them. And the heat sinks are below the capacitors, not good design, so the heat's rising up through the capacitors. I'd say they're all going to be dead. I don't want to risk doing more damage to this thing. Now, if I put other tantalums in, they should be fine, but they haven't been exposed to voltage for a while, so the tantalums themselves also need to reform. So I need to be careful about that as well. So I'd rather blanket replace the whole power supply, do those in one go, and then revisit it. But unfortunately, because of long weekend, it's probably going to be at least 2 weeks I've got the parts, because they're probably going to come from Australia most likely. Especially the axial ones, they have to come from usually element 14. Because RS don't tend to carry the axial capacitors, and their axial caps are expensive. I may also consider using Arrow in this case, because I'm be getting so many. Arrow might be cheaper. We'll see. I have to look at it, but yeah, obviously I can't do any more right now. This is where I'm stuck to right now. So. I've got so many capacitors and I still don't have the right ones. I do have a box of parts. Is there a chance I've got the capacitors in my parts bin instead of in the drawers? Because I've got more drawers which are fairly full. Let me check this. Just rule this out. Let's get the right one. I know you can't see what I'm doing right now, it's not exciting. Well, I suppose I could show you my parts bin, couldn't I? Give you an idea of what I have. So this is my bin for my general semiconductors and bits and pieces, overflows, things that don't fit in my parts drawers, or excess parts where I get too many, because that never happens, right? There's a bunch of capacitors in here. I'm not sure what else you got. I think these ones I bought when I was doing my TV. That is a 1000 microfarad 63 volt. Oh, got one. I might search through that bag. What else have you got in here? 4725 volt. Got some valves in here too. These are spares from one of my best test gear. Some MOSFETs, Zener diodes. That's those 25 volt ones on the tip before. What are these ones? 1000 microfarad 25 volt, again no good. $3,335 volt. Oh, close, but it's radial, not axial. I'll pull those out anyway. $1,000 microfarad, 63 volt. Look at that, I'm saved. Excellent, I can do some of them. What else have we got in here? It's 25s. It's 47 microfarad, 400 volt, not quite right. Small 25s there. Right. Some fuses. Oh, that's where they went. We're looking for them. They should be somewhere else. Somewhere. No, I'll put them in a bit there. Right. Okay, so things are looking up. So I've got the capacitors which will replace those ones. I need 6, 7. I have 8. That's good. So then we've also got the 63 volt 470 microfarad. I might have those anyway. Those are big. 35 volt. Yeah. What's that one? There's a 50 volt, might be enough. If I've got 2, I do have 2. So that might be enough. 50 volt. I have to look at the power supply diagram. So that might be okay. It's looking up, so I can do those ones. And I've got 3300s, but they're not axial, they're radial. That's a small sacrifice. So you might be able to do that power supply ball. And that's 4716 volt. I did have some. Was these ones? No, where are they? I've had them here before. But let's see some. Anyway, I think I've got a capacitor for that, haven't I? So I just don't have that one. That 10 microfarad 350 volt. I don't have that one. Unless I've got it in this bag here. These are capacitors I bought for doing my TV. But I think I've got a whole bunch of random ones in here as well. What are these? Good question. Don't know if manufacturer part codes. Doesn't necessarily relate to the part. 390 microfarad, 63 volt. So no. What's this thing? Special thin ones. 18 microfarad 450 volt. That's a contender. Although it's the wrong package type, but it doesn't matter that much. Come on, what is this thing? Is that a 390 35 volt? Yes it is, 390 35 volt. 63 volt, whatever it is. 1063 volt, got some more in there. But these are a lot bigger. I'm worried about the size actually, those ones. These are 560s. Oh, these are small. What are these things? Can't tell from that. 22 microfarad, 63 volt. I've got these special ones here. There's a 18 400 volt there, a couple of them. So I could potentially replace that with an axial radial with a slightly higher capacity. So I have most of the parts in a kind of bodgy way. move these SMD ones out of the way. Only then. Okay, well, I've got I'll find them all again now. These ones. We'll put these on. Let's do what we can, because I do want to power this up. I'd like to get this thing powered up today and do some testing on it. So let's take out all these ones and make sure I get the polarities correct. They do have a square pad for the positive. I just want to make sure the square pad's in the right place for all of them. Sometimes they are wrong. They do, that's all good. So I'll take all those out in one go. Go on, fall out. So what? I suppose I could test them as well once I pull them out, eh? Just out of curiosity, see if that actually does work or not. And might have the camera turned off, it doesn't matter. Fall off, you bugger. One more down here. Okay. That's those caps. These ones will hopefully fit. Now I've taken all those out. Sizing is the same. In fact, they're slightly skinnier, I think. Not much in it. So that's good. There's actually a little bit of corrosion on these top pads here. Just clean those up a little bit. Get the flow through properly. Fiberglass brush. Can't say, a fiberglass brush is really good for this. That's what I'm using. Because it's slightly abrasive, but not so much it will cause a lot of problems. It's not scratching up a lot. So that just means I'm getting a nice clean pad at the top. So when I solder it, it should flow through nicely. In fact, I might put a little bit of flux on that side. Maybe. Yeah, I'll put it on. just to help it seems they've not been done properly in the very first place. I don't think they had any solder on originally. Haven't flowed through. So I put a bit of flux on here and it should flow through a bit easier. And wick over a little bit better. Right, let's shovel these in the correct round. Double checking. Not paranoid at all, honest. So nicely, these are an upgrade, which is always good. I like to upgrade if possible. So the advantage of technology improving, in the capacitor technology, where now they're a smaller size for the same equivalent ratings, which is great. So obviously high voltage is an improvement, I suppose, although higher capacitance might have been better. These two are indeed in parallel, these 100s, also use 1000 on the end here. That's what I thought. So I could have used 2200 instead, but I think I would have been struggling with the height. So now I normally use my silver solder, but because, maybe I can. You're probably right, probably flow through. I was thinking about being power supply and being a bit corroded there, and my soldering iron's turned off. Let's record some video on this. So I pulled all these capacitors out. These are 1000 microfarads, 40 volts. I'm replacing them with 63 volt versions. That's what I've got on hand. I had to go digging for them, but I found them, thankfully. So now I'm just going to solder these back in again. And then we'll go through and see what else I can replace without having to order any more parts. I think I probably will have to do some ordering. But we'll see how we go. It would be nice to get these power supplies rebuilt and refurbished today so I can do some testing. So I don't want to power it up again until the power supplies are done. So what I did do before I started recording is I cleaned up the pads on the top of the board because they were a little bit oxidised. But the solder hadn't originally flowed through from the other side of the board when I did the original manufacture. So I gave that a bit of a clean up with my fiberglass brush and put some flux on that side before I pushed the parts through, so that would have pushed the flux through the board, through the wires, or the through holes, what we call them, plated through holes, onto this side a little bit as well on the pad, so it would have flowed through a lot better when I soldered this side. So now it should have actually flowed solder through onto the other side of the board, hopefully. Right, let's clip these off. So that's those ones done. So we've got these ones over here, which are 470 microfarad, 63 volt. So we need to look for those. I've got some 50s, I think. I've got 50s, but I don't know if that's going to be enough. Or maybe I need two. I was going to think I could put the 1000 microfarad 63 volts in here instead of 470s. These might be done that size because of the physical restraints on size, right, in that placement. You couldn't have anything bigger in there for that voltage rating. But I've got these ones, but I've only got one left now. I think. I do have something in this bag. Was it that one or a different bag? Or maybe I do have some more, actually. If I do have some more, I'll replace those, I'll upgrade those to a larger capacity. That's what I'm tempted to do, maybe double them. It's possible. Let's come back to the chat. Okay. We'd still get taxed, Johnny, for that tax treaty. We get a lower tax rate. Some things, some aspects aren't taxed, but some are. So we still do get taxed. I think it was a lower rate though. It wasn't a full rate or anything. DigiKey, yeah, I've never actually purchased DigiKey, I think. Maybe once. Yeah, the desolder gun's got a little plastic tube on the top that'll clear, well, kind of clear, a darker plastic tube on the top. You have to pull that out and into it once in a while. If you still see through it, it's good for more. Yeah, well, mine's pretty dirty. You can't see through it anymore. Heiko FR410. Oh yeah. Someone, who was it that approached me? A company approached me about a month ago now. Who was that? Can't remember who it was now. But they do a lot of soldering stuff. And it's going to bug me who it was. I think they were just advertising, just, you know, trying to get people to buy stuff, you know. And so they actually contacted me through Twitter, I think it was. It might be Facebook, one or the other. So I said, you know, email me and we can discuss stuff. And they emailed me, sounds great. I replied to them. I said, great, I'm interested in sponsorship stuff. I'm interested in these particular items. And, you know, if you want to send me one of these, that'd be great. I can do a review on it. No response. So I think they were just fishing for advertising and trying to do sales. They're the sales team rather than, you know, sponsorship opportunities, which is a bit of a shame because they had some nice soldering on stuff. I was quite tempted by that. Tweezers and stuff. And I was like, oh, tweezers, that'd be nice. Fortunately not. Can't always get free stuff. It's nice, but if you can, but. FR410, I think I looked at the FR410 some time ago, I think. It rings a bell. Yeah, I mean, it's still a Chinese solder stock. I mean, it works okay. It wasn't that cheap. I think it was about 150 US or something like that. I think it was. But then I got it as a review item, so it didn't cost me anything, so that was good. Even better. But you can get like a dual version. It's got like dual motors in it, or dual. I think it's got one motor with dual solder vacuum pumps on. So in theory, it's better. It's about $50 more, I think it was, something like that. I've got that on my wish list for maybe one day if I get a quiet time, mate. Nothing else around, I might grab one, a better one. But it's still not as good as a professional grade unit. Definitely not. It works. You have to keep cleaning it, and yeah, it's okay. It's easier than using solder wick. Yeah. Right, so let's look at the circuit diagram for this power supply. First, I've got to find it. Right. Did we go past it when we were doing the initial stuff? Possibly. Yes, we did, because this is the power supply board. So that's good. So we're looking at C10 and C21, looks like. Those ones there. There's C10. And there's C21. So they're in parallel together. So I could actually replace that with a higher capacity, single higher capacity one. Oh, that's sweet. I could just take those two out and put in one of those 1000s. That's all I need to put in. That'd be good. What is the voltage on that supply though? So that's what I'm looking at is here. That's that pair. Don't know what supply rail is. No idea. It doesn't stipulate. That's interesting. 22 microfarad, 25 volt. I wonder if that's one of the tantalums. Another one there, 16 volt. Those aren't what I'm seeing on here. They're probably all the tantalums. Right. So yes, I can put that single capacitor I've got left, that last one, that 1000 microfarad, 63 volt, drop that in there, that give them a slightly higher capacity. That's good. I'm definitely puzzled by this though, because this looks like they've done a design change. Yeah, that's that entire board. That's it. That's the whole board there. So we did seven 1000 microfarad caps. There's 1, 2, 3. Okay. Where's the other 4? I'm missing something here. So 3, 4, 8, 9, 23, 24, 22. You got that? 22 is 22 microfarad. Was that 27? (23, 24, 21, 22). Okay. I'm obviously missing something here because there's caps which aren't listed on that diagram. C9. So 3, 4, 8 and 9. Okay, where are they? They're not on there. And that's not the same board. That's interesting. Oh, well, we'll carry on anyway. So it looks like we can do those other two just fine. It just makes no sense. Why are they not there? Did I decide I didn't need them in the end? Just 1000 microfarad across there was enough. That's weird. Odd. Anyway. So I'll replace those two with one big cap. And then I'll do the tantalums and that'll be that ball done. So it's 12:30 now and my throat's getting sore from all talking. 4.5 hour stream. Shall we keep going? Code beat. 2:33. Yeah. Early in the morning, eh? It's trouble with doing streams, isn't it? You know, since the worldwide time zone problems. Everyone should live in the same time zone. Flat earthers be united. Everyone would be on the same time then if it's flat earth. What do you reckon? Okay. What was I doing? So, I don't know if I can use 50 volt caps because it doesn't stipulate what the voltage is. So I think I'm safe using one big cap instead. So that one I just pulled over, that one there, which is the last one I had, can go on that ball. Just to make doubly sure, they look like they're in parallel. Let's pull them off. And I forgot to change the camera view so you can't see what I'm doing. Because I'm an idiot. So that's those two. Right, I'll chuck those in, and yep, they are indeed in parallel. So that's fine. I'll just put one big one in instead, and I'll put it over here, further away from the heatsink. That sounds like a pan, doesn't it? Do you know what those pads like? Do they need cleaning? No, they're fine actually. Those ones are alright. Can I sleep again? Yes it has. So those two capacitors pulled out, which are the 63 volt 470 microfarad, they're in parallel together. So I can actually replace those with one capacitor, which is great because I've got one capacitor left, which is 1000 microfarad 63 volts. So that's fine. It's actually upgrading the capacity very slightly at the same time. So that's fine. I'm happy with that. So we'll just solder these on. Now actually what I'll do is I'll resolder the original pads as well on the other one, which I'm not replacing. This has got a solder link between each side of the board, just to help reinforce it in case it's required for current handling capacity of the power supply. I've been relying on the through-hole plating, because before it did have a component through there to do that job. So now it's got to do this to make sure it's got some flow through. Just like that. It's flow through, not well, but it's through. That one does need cleaning. give that a bit of a touch up. Didn't flow very well on this side. Didn't have any flux on it either, so that didn't help. There you go. That's flowed better now. Might do this one that's next to it as well. There's one here. Okay. So, what next? Got a little electrolytic down here, 10 microfarad, 63 volt. That should go. I think I've got a few of those. I think I can spare one. The odd ones I can shove in there in case I've got some random thing. I'm using sets. I like to keep the sets if I can for other stuff. I'll do a random one in there. Let's get that out. Oh, that's part of a set as well, so that's fine. I'll grab all these ones in. We'll swap that one out. This is why you see me buying lots of capacitors in mailbag, because I need them. For these times when I'm working on something and I just happen to need to replace it. So, never quite know what I'm going to work on, what I need. That's why I keep a stock, as much as possible at least. Well, let's get this one out. Come on, melt. Not sure it's coming through yet. Yeah, it is. There we go. Right. Which way around was that? I think positive was upwards, wasn't it? I think it was. Which way around was that? Yeah, it was. It was that way around. That's fine. It does have a square pad to donate positive, but don't trust those because they're not always right. So we've got these electrolytics over here, which are 3,300 microfarad. Now, the only ones I've got are radial. So they'll fit, but the legs won't reach. It's not an ideal situation. Because there's no way I can fold that right round and get it right round to the other end. That is not going to happen. If I use those, I have to extend the legs. Are they in parallel? If they're in parallel, that'd be brilliant. They don't appear to be in parallel. Because if they're in parallel, I could potentially use a much larger capacitor instead. Let me double check the diagram. So, I wonder if I've got a page missing off this diagram, stuff which doesn't appear to be on it. Where are they? Over here. C1, C2. I don't remember seeing those on there. I wonder if there's a page missing. Of course, they're definitely not on that bit. Is there like a skip page maybe? So I'll have a look on this one in case anything looks vaguely right. No, definitely not. That's out of the board anyway. This is all the power amplifier side of it. What's this board? Upper power amplifier? No, might be on that. I don't think. No. Let me start chat. Yeah, I think there might be a page missing because there's capacitors which are on that board and parts on that board which aren't on that manual. Mind you, this is for the maybe this is part of the problem. This is for the 4708, right? Mine's a 4700, but this is the only available manual, right? But it's basically the same thing. Maybe that's why there's a difference. Although they're pictured on the layout, so that makes it even more confusing. Because the layout says they're there, but they're not on the diagram. So it's the in-guard power supply assembly. This is sheet 2. This is sheet 1. One was supposed to be a sheet 3. Yeah, because there's a lot of extra fuses on here and stuff like which aren't on the other diagram. Okay, I think I might have some other diagrams. Let me just have a look. Do I have anything else which might potentially show it? So I've got another one. Okay, but the reason I don't test the caps first is because I could see physically that some of them are already bad. And this thing is 30 odd years old. Was it 30? It's 1988, this is dated. So this thing is 31 years old. 33 years old, get it right, 33 years old. So because of its age, a lot of these capacitors are going to either be bad or failing. So they might, even if you test it now and it tests good, it might be bad in a year's time. So it's just not worth bothering, just change them. My experience has been just change them, it's just not worth messing with it. If it's only a couple of years old, then sure, you may not be bothering to replace every capacitor because chances are it'll be absolutely fine. But in this age, then not so much. So I just found another manual which hopefully has those diagrams in it. Let's put this up the top. So I've got to try and find the right page now. I'll just sort of jump right down to the bottom somewhere. So actually, I'll show you this one here. So I was saying about before, those big capacitors down the side. That's them right there. And those are these fuses I was looking at here. So there's a fuse there, which I could see, those two. And there was two surface mount fuses, which I can't see here. Oh, there they are, there, right there. But I surface mount there. Smaller fuses on board mounted there. There they are there. So those fuses there tested okay. Don't think there's any more. Anyway, whilst I was here, I thought I'd mention that. Let's find this other piece of the board. Right. hopefully it's here. Which makes it, it's for high voltage. So okay, we've got a little bit away from there. That's that one there. It's one of the power supplies. Could it be on here? So I'm looking for C1, C2. If I can find them in the 3300s, then it's a possibility it's the right one. No, there's C1 over there. That's not that one. Okay, keep going. So it's the same diagram we had in the other manual. Yeah, it looks essentially the same. Okay, now I'm really puzzled by this. So you've got two manuals, both did the same thing. But then it might be the same manual anyway, so it's not really a complete difference. Do I have any other manuals? Here's another version. It could be the same unit though. It's the same unit, so probably not that helpful. Let me have a look. Right, away from there. Probably exactly the same. Yeah, now we get this soon. There's a large caps and stuff on that one. What's it on? That's on the. It says DC assembly. Could be DC generation assembly, not the power supply. So you have a plus and minus 38 volt hour here. I wonder if that's what that board's generating with those 63 volt caps. That will explain the voltage. Come on, where is it? Just looking at random diagrams because I happen to find what looks like it might be the right one. That looked like a bunch of changelog stuff, didn't it? Come on, where is it? There's not that many boards in this thing. Oh, go on, pass lists. There's some more. Since a deja vu, like I've seen these boards already. what is this one? Amp guard power supply. Could this be part of it? Doesn't appear to be. It's probably a separate board. Here's what we're looking at. This just made me wonder actually why it's, maybe it could be on this one. 4700? Nah, it must be the other board. Okay. Let's look here again. Sense of deja vu. Here we go. This one's got the right caps on it. This one's gone. Current option supply. Ah, maybe it's a variation of the board depending on what options are installed. Right. Okay. So looks like I have to use this manual. Datron 4708 is a calibrator, so it outputs voltage, current, resistance, and AC and DC voltage and current, I should say. So it's for calibrating bits of test equipment. So you can use this thing to calibrate a multimeter, for example. That's what it's for. That's why it's a big bulky piece of test gear. But these are old and very expensive. So this particular gear, if you can find a working one, you're looking at about $10,000. This one I picked up broken for about $2,500. I paid for this broken, US, plus postage, plus import fees. This cost about $5,000 all up to get this unit, and it doesn't work. I knew it wouldn't work when I bought it. All good. Okay, I was going to text you.
You were going to text me.
Thank you, brother Calibrator.
That's outrageous.
Yeah, so there we go. That's that. That's why that's different, because that other one didn't include the options for the calibrator, which is why this one's different. So that's why I've got these other caps on this one. So it probably needs a more robust power supply because of the extra options that are installed in it. If that makes sense. Alright, so now, C1 and C2 are positive and negative power supply rails. So no, they're not in parallel. So that's that question answered. Oh. Is that a capacitor I lost? Yeah, it is. No, capacitor went flicking across the room. It ended up on a cup. I must end up drinking that. Tantalum stew. Wonder where it went. Oh, that's hilarious. Okay, so yeah, I can't just beef those up as such. I should be okay increasing the capacity if I've got something of the right voltage. These say 25 volt. Okay. What rails are they supposed to generate? Plus or minus 22 volts rails. Oh, 25 volts a bit close for that. So I probably need 35 volt really for those, to be sure. 25 volts is definitely way too close. Yeah, no, Curious Mark, yeah. He does some interesting stuff too. He does slightly older gear than me. He does generally like 10 years older than what I do. So he does some interesting stuff. I follow his channel as well. Ooh, oh, more snacks.
Lunch. Barbecue
lunch.
chicken wrap.
Ooh, barbecue chicken wrap, got that. This might solve the sore throat problem. Right. Yeah, FranLab. To be honest, I don't watch FranLab that much. I have watched her a few times, but I don't know, it just doesn't really... what she has... Well, the videos I've seen of hers, at least, I could be completely wrong. They weren't really in line with the sort of thing that I'd be interested in. Not exactly, so... but she's certainly got a big following. She obviously does a lot of stuff which interests a lot of people. Yes, and that, I've got a problem now. Do I work or do I eat? I think I might have a bite, I reckon. What pollutants could possibly be in my hands from working on this piece of gear from 33 years ago? Right. So let's look at what capacitor's got to put in here. Well, I've got 4,700 microfarad, 25 volt. But like I said, 25 volts and a 22 volt rail was a bit close. Well, I've got 22,000 microfarad at 40 volts. I need something sort of in between the two, don't I? And those 3,300 I've got sitting here, they were 35 volt. So that'll do the job nicely. Let's just change this wrong package style. Oh, my wrap's undone. It's everywhere now. Oh, I have to eat it. You don't want to see me. You don't want to watch me. Yeah, look at the desk. Look at the messy desk. I'll try and make some room and not close windows and stuff. Right. Chop. Yeah, I'm sorry guys, you might actually hear me eating on. I suppose we don't like that anyway. Ken Sheriff. I'm not sure. I'm not familiar with that one. I may have seen him on Twitter, maybe. I'm not sure. Maybe I know a few people who do cat things like ICs and stuff like that. There's a few people that do it. Maybe it's him. I've seen. I'm not sure. Right. Look at that bit, not this bit. So yeah, that's what we need to fix, is that bit there. It's just shut down with exactly the right parts. Slightly annoying. So it looks like I'm going to have to reference this manual instead of the other one. It looks like it's probably more appropriate to my model. Right. So there's not much left to replace on that particular board. Got 2 electrolytics and then tantalums, and that's that board done. Now, something I should do is actually check the bridge rectifiers, because the W001, I'll start again, the W001, that rectifier is used in the Datron 106.2s, and they're prone to failing. So I should probably check that as well to make sure that that's not a problem. Oh, thanks, Peter. Give us more money. Too generous, mate. You keep giving me money. Thank you very much. Right. Nearly finished eating. Sorry, guys. So I'm inclined to. I mean, do I put the voltage rating close, as per the diagrams, or do I substitute a different footprint part? You know, so using a radial of an axial. Mako, no, I didn't see a link post there. It could have automatically been blocked by YouTube. Give me a second. Try again. $26°C in my office here, yes. It's probably about, well, I can tell you exactly what it is outside. It's 22.7 degrees outside. Yeah, make I made you a moderator. No, you can say as a moderator, you're right. You're not exactly troublemaker, are you? So, yeah, so I'm in New Zealand, to answer your question. And it's say nearly 23 degrees outside. Right, so I'm kind of inclined to go to the option of the wrong footprint part and using the radial part with the higher voltage rating and having to run a little extension wire around and link them together. Because I think that's going to be better overall. New Zealand is further east than Australia. So, it's, I don't know, what's the distance? Must be a couple of thousand K or something like that, I'm not quite sure. It's a fair distance away. So, not Australian, but New Zealand. It's 21 down there, is it? Where were you, Johnny? Was it Wellington where you were? I can't remember where we were. Palmy, right, okay, yep. For those that don't know what Palmy is, it's Palmerston North. In case you're looking at a map trying to find Palmy. Alright. So, food is finished. Still got my coffee, which is fine. I can sip on that. Hopefully I'll drop any more capacitors into the cup. That'd be quite good. That's funny. Right. Shall we check these cats I've already pulled out and just see what the stories with the ones I've already done before we move on to bodging the circuitry? Let's get my meter out. Let's try and get it on the desk. Hold on. It's getting a little bit crowded around here. Right, can you just kind of see that? Right, let's change this around. Series capacitance, ESR, 100 Hertz frequency. I've got this thing on here, which should be right. So it's 0.2 ohms, 8.2 microfarad, sorry, 830 microfarad. That's 1000, and that's slightly bulged. Next one, slightly bulged. 0.2 ohms, again, very similar. Lower capacitance, not bulged. Capacitance is way down, this one. That's a 470, that's why, 63 volt 470. So that's way down, that capacitance value's off. There's another 470. Ooh. Eggs. Look at more food. So that's 390. That's also way off. Look at. You know, I think it's Easter or something. So it doesn't measure this one, I don't know. Probably did. So let's do another 1000 here. That's down. Resistance is slightly better though. Not bulged. Next one. Another 1000. Resistance slightly better. Again, capacitance is down. Slightly bulged. Next one. Capacitance down, resistance is slightly higher. That's bulged. This one here. Again, capacitance is down a little bit. Resistance is not too bad. Not bulged. So you can see the fact that resistance on the ones which are bulged is higher than the ones which are not bulged. So that kind of reinforces that, doesn't it? Here's a. I'll try and find my comparison. I'll put them away now, haven't I? It's a 1000 microfarad. This is 63 volt. Hey, I did have some more. It's up there. What do you get in this one? Want to get a good connection? Come on. Give me a good connection. Well, that's not looking good. Don't know. Not sure as that one is. Still struggling with that one. He's not liking to read. Doesn't want to read this one too well. There we go. 930 microfarad, 0 ohms effectively. That's what I'm trying to get out of it. So that's close to what I'd expect. I mean, you yourself. Worst case, you've got 20% error. Worst case, usually you're closer to 10% error, depending on the cat brand. So these other ones are right on the bottom end of that 20% region, you know. So, but there's some 10% out of that one. So what else we got here? You've got that 10 microfarad here. We pulled out. Let's check this one out. Just making sure we get a good connection on it. Try to. Get a bit of solder on. So yeah, this is the 10 microfarad and nowhere near that. You're getting nanofarad and 28 kilo ohms. So that one there, definitely dead. And it's a Philips cat. What's this one here? 100 volt, 10 microfarad. 10 microfarad, 5 ohms. That's probably right. Another one. Exactly the same part. Yeah, 10 microfarad, 5 ohms. That's probably fine. Because these are low voltage. Sorry, high voltage. They have a different requirement. So those two might be right. But doesn't matter, they're replaced now. That's fine. I'm not going to, I don't know, just measure a tantalum, shall we, just for the sake of it. 10 microfarad, 3.1 ohms. Yeah. They don't really get the same effect out of tantalums though, either good or not. This one which is next to the one which blew up. Yeah, 23, 3.6 ohms. And what that was a 22. So, yeah. I mean, they're probably alright as tantalums, but they could have been stressed, and so I just want to take that potential exploding bomb out of it. Right. So yeah, like I said before, I think I'm going to use a radial cap in the actual location and run a wire around to the other end, because these are at least a higher voltage rating. So it gives a bigger window. These are really pushing it. Even though maybe it should be fine. It might not be an issue at all anyway. Yeah, obviously still got to do these ones yet. But that's not such a big deal. Yeah. Let's move some things out of the way before I get time to put chocolate. Go and check the chat again. In fact, I'll turn this off now. Right, where we at? Get outside to find a missing one. Yeah, and these temperatures probably melted. Philips, yeah, I mean, Philips caps are okay, but when they're 30 years old, not so much. They don't last as well as some of the other ones. Chocolate eggs. Is it 3 or 4 hours flight to Australia, something like that? I've been over there once. Been to Australia once. I actually visited Dave Jones at the time. Dropped into his lab and said hello to him. Some of you may or may not have seen that video. If you did. So I've visited Dave. Spent the afternoon with him. Well, spent basically the morning and afternoon with Dave. Myself and my wife went over there. And really nice guy. Got a lot of time for Dave. He's genuine. And the difference between 0.1 and 0.2, well, you think, you know, as a ratio, one is twice as much as the other, so that's twice as bad. But when you've got such a low measurement scale like that, you know, it's not great precision. There might be almost nothing in it. Kim wipes. Yeah, Keysight wipes. Yeah, they're just quite good for soaking up alcohol when I'm doing cleaning on the boards. They're quite absorbent. It sucks all that up, so that's quite good. It's good at getting the flux into them. They don't shred like tissue does. Tissue will just shred. I've tried with different kinds of ones over the years. I've got some quite good ones. They work okay, rather. But each thing's got a different use, really. Some things are good for rubbing boards. Some are good for absorbent. So if I'm not doing anything particularly critical, I've got my cheaper ones, which are just little makeup pads, basically. Makeup pads, that's all they are. And they work fine. But the Kim wipes are pretty good. I haven't had those very long. I got them a few months ago, really, I think. Just before Christmas, I think I got them. And I thought I'd give them a go because someone recommended I try them out. And yeah, they work fine. So I'm quite happy with them. They are just like paper towels, really, but they're quite nice. Right. So on this board, as I was saying before, we have 3 bridge rectifiers. I want to test those. Let's get this out of the way now. Before I forget about testing them, I want to do it now. Because I won't forget to replace caps, but I might forget to test the bridge rectifiers. And it's super important to make sure they're okay. Now I might be able to get them from the top side. It'd be quite convenient if I can, because I'm going to see markings. So let's do that one. that's good. That one, yep, that's good. Reverse them. Yep. Yep. Yep, that looks like it's probably alright. Or is it? Oh, there we go. Bad connection. It's fine. It's right. And okay. So it's going to be charging up the capacitors and stuff like that, so I'm not too worried about any weird readings. I'm just looking for basically a short or fully open. So let's see if we can get onto this one as well. A bit harder to get into this one, I think. Can't really get in there very easily. Got that one. Right. Yep. 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 Yep, that's right. So that's two rectifiers, that probably fine. So it appears that way. Yep. So those two are right. So you'll check this one, which is going to be a pain to get to, so let's do it from the back. That's the 80 terminals there, so it's AC to that one. It's okay. It's probably alright. Okay. Probably alright. It's open. Okay. Okay, so bridge rectifiers check out alright. Also has some discrete diodes in here as well for higher current handling. So let's just check these. 0.5, 0.5, 0.5, 0.5, that's sweet. So let's go in the other way. Make sure they're blocking. Yep, it is. Charging caps, that's fine. Yep. Yep, fine. So those are looking alright. At least the bulk ones, those are the main bridges. I suppose I'll go check the other ones to be sure. I mean, I'm not expecting any particular faults in these areas, but let's just do it. Seems it's not much of a check. That's fine. That's fine. Another one down here. That's fine. Another one more here. That's fine as well. And there's another little diode here which might be a Zener. I think that's probably a Zener, that one. It looks normal, that's fine. So I think we're alright as far as diodes on this board at least. Whether the regulators and stuff are okay, don't know. So we got a 7815, a 7915, 7908, 7808, 7915 CT, LM317, which is probably a 5-volt regulator, and there's a 7805 over here as well. So we've got several supplies on this one board. Looks promising at least. Power supply is an easy thing to fix. You know, they're easy to diagnose, easy to see what's going on, and check for ripple and all sorts of issues. I mean, I can actually power this up from an external supply. I'll hook into these regulators, bypassing the bridges. Or you can go before the bridges really, and run DC through them, doesn't matter. And I can actually diagnose and check each power supply is okay. I could even do that if I really wanted to. But you wouldn't see ripple, you only see the upper voltage, you wouldn't actually see any ripple content because obviously you're powering it from DC, not AC, so therefore you're not going to get any ripple. Anyway, so let's get these changed out. I'm not completely happy with what I'm doing though. I would prefer to use axial caps. It's kind of annoying. I don't like to do things like putting radials in actual positions. I don't like to do that. It's not ideal. Or I could test them, see how they look, and to see if they look like they're going to be alright or not, because they may be fine. But there are 25 volt caps on a 22 volt rail, which is really pushing it. That means the spikes and like the AC ripple that comes through are going to be pushing the limits on these caps. Not ideal. Let's test them. Let's see what we've got. I might just test them, leave them in there for now if they look okay, and order the right parts and change them when they turn up. I think I'll do that. Guessing you guys can see that alright. It's a bit annoying. Every time I want to do this, I have to go and push buttons, change it for capacitance, change it to series capacitance, change the frequency to 100 Hz, change it to ESR. Let's clip it on, see what we get. Well, that looks fine. So that's 3,190 microfarad, 0 ohms resistance, or ESR. I should check dissipation as well. Let's check this one. Should be the same basically. It pretty much is. It's slightly better. If I compare it to this brand new cap, yeah, this is actually slightly lower capacitance. But it's within tolerance, you know, say 10 to 20%. So let's choose dissipation. Sometimes it shows something up. 0.18. Yeah, okay. It's not horrendous. Get that on there again, come on. 0.18 again. I'll show you on a comparison cap. 0.14. So it's only slightly worse than a brand new cap. So I think I can probably get away with leaving those in there for the time being. So I'm happy enough with that. Tantalums on the other hand, I'm not so sure about leaving them in there. Maybe on the low voltage rails it'd be okay. I need to maybe just leave them in some cases. Like 15 volt rail, that'd be fine. As long as it's got a 35 volt cap in it, or 25. Let me look at this. What do we have? Apart from the inability to focus because I'm so damn close. Right, there we go. That's a 2216 volt. There's another 16 volt. What rail are those on? 8 volt rail. Ooh, that's double. Barely. It's close. Not ideal. What we've got here? 25 volt and a... don't know, it's backwards. It's probably another 25. Come on, focus. Yeah, it's number 25 volt, and those are on 15 volt rail. 10 volts, it's less than double, so those will need changing to 35 volt ones. They've got more, another 15 volt rail here. What's that got on there? It's got 25 volt on it. Again, marginal. The 5 volt rail, that should be fine. I imagine this has got some massive camps on there. 25 volt. So yeah, these 15 volt rounds, downly changing. The 8's borderline. 15 over here, let's say it was. So look at that one. That's got 25 volt on it. So yeah, I think that all those rails need replacing, really. I think the only one to right is the 5 volt rail. That's the only one that's okay. The rest need doing. So I better do that, I suppose. Oh, yeah. Any trouble posting links, are you, okay? Trying to get them right. Short links are usually okay, unless you maybe have an error with the URL information. Chocolate eggs. Right. Right, that's cool. You guys chatting myself, that's good. So let's do some more replacements of tantalums, because these aren't good enough. They're way too close. I mean, you look at ratings, oh, it's rated for 25 volts, and okay, it should be safe up to that voltage. Now it kind of is, but if you get any ripple on that supply, then it isn't. Now tantalum's like a big window. So let's start over here, and let's double check these ones. Where is it? Now it's not getting close to the damn thing. Right. Where's the ball? We can't see the ball in the microscope. Here we go. Get in there. Right. So yeah, it's definitely 25 volt ones on the 5 volt rail. Yeah. I think it is anyway. Yeah. So there's two capacitors there. One's on the input, one's on the output of the 5 volt regulator. But I'm thinking that... Have they done that? Just trying to see how the traces go. I can't see where the input's coming from. Maybe just did a whole lot in case the input's a bit dodgy. So many tantalums, it's incredible. So that's 22 microfarad, and another one is a 22 as well. It'd be nice if they're all the same part. I'll be surprised though, but it'd be nice. It's 22. I'll look at voltage for, should look at both, shouldn't I? 22, 22, 22, but lower voltage. Okay. So I think that's using a generic value to try and help filter out any potential supply rail noise. Where is it? Can't see it. It's also 22. So they're all 22 microfarads by the looks of it. There's one I can't see which is behind this other regulator right here. Can't see what that is until I get it out. But there's a good chance it's also 22. So, do I have enough 22 microfarad caps? Do I have any 22 microfarad caps? Oh, actually, that's a point. I don't have any. I'll put those in the second whole place. That's not helpful. At least I do. I'm doing that. There you are. So yes, I do have them. That's great. I've got a bunch of them. That's 33, 35s. These are 22s at 35, I think. That's what they were. Yeah. So I've got plenty of those. That's fine. I shall replace all of those with 35 volt versions, and that'll be that board done then, hopefully. In this case, as they're pretty much all going to be the same one, I'm just going to whip them all out and replace them in one go. Instead of messing around, at least the ones that are facing the same direction. Don't want to get these in backwards. God, slipping. So the ones that face one way, I'm going to do, then I'll change directions. That way I know where to. Mind you, it should be obvious in the way for the fact that these are much bigger. Just don't accidentally put one in backwards, that's all. So then we've got the other board to do, which isn't going to be much. And then we can maybe power it up. So what I really want to do is get the thing powered up and see if it changes anything. See if we get any more magic smoke come out of it. or any magic smoke coming out of it. Right, let's do the other ones which face the other way. It's a bit of a weird arrangement. It's got like a resistor and a diode leg going to the same hole. Oh, sorry, resistor and diode leg, resistor and capacitor leg going to the same hole. A bit strange. A little factory bodge. It's attached to that resistor right there. Mustn't forget to do that. If I can get it off the resistor. Yeah. So the resistor's across the capacitor. Interesting method. There's one just down here. Like I said, I'm not sure what that actually is yet. At least I can see which way the positive goes. Come on, bubble. Ah dear. Come on. Fall off. This one's awkward because of where it's sitting. Can't go all of it properly. And it's got a resistor around it as well, that's why. Interesting modifications from the factory. Okay, got it out at least. I'm assuming it's a 22. It is. Right, I've got to try and get that through the resistor again. Very interesting setup. Okay. Bit fiddly because I've got to try and melt the solder on the resistor to get it pushed through. And I've also got to try and get the other leg in. Right, progress. Right, done. Weird setups. Still got two more to do yet by the 5-volt regulator. Slow process, way too slow for my liking. So I've still got two more to do over here. Just trying to see if those resistors are soldered onto the legs properly or not. Might just do a bit of solder on there to be sure. This one gets to that one. Don't think I can get to the other one. Don't think I can get down there without touching something. Come on, solder. There you go, got it. Right. And I did just touch the solder cap, barely, as I was putting the soldering on it, looks of it. Okay, these two there, then that's that board done apart from those two which I might mark as suspicious for the time being. Target parts. So I shall do question marks on those so I know I need to check them. Well, I need to potentially replace them. Let's get these ones done. That's nice. Easier. So normally with tantalum capacitors and most of the gear I fix, I don't worry about them. I just leave them in place because I've never really had any problems with tantalums apart from when there's been a main power supply problem. But in this situation, it seems that the Datrons, at least the calibrators, they didn't leave enough margin for the caps. So as a result, they've been problematic. So in this case, I'm going to have to do them all, even though normally I wouldn't bother. It's a bit annoying, really, because I'm probably replacing parts with, well, replacing expensive parts with more expensive parts for no good reason in most cases. But as I don't know about the power supply stability and that sort of stuff and what it's been doing in the past, I can't really risk it in case they've been stressed a bit and then they explode and cause some major damage. There's lots of parts I've done this thing. Did I miss any? I mean, cleaning a power supply is less critical than some of the other areas of the unit, which will require really clean circumstances. But power supplies, you know, you don't really have to worry about that much. It's just nice to have it clean, that's all. Okay. Not too bad. Okay, mischip my work. Looks a bit close, done like that. It's a bit fluxy around here. Okay, we'll call that ball done. I really hope it works. Okay, put that to one side. Now look at this one. This one's easy to do. That cap there, 4700, that I thought I had. Now, what's the difference here? 16 volt, and I've got 25 volts, so that's fine. That's an upgrade. So I'll pop that out. Try and go into this one, that melting the connector because it's right next to it. easy to get that one. Is it glued down as well? Yes, of course it is. This one's going to be fun getting it out. So I'm going to need to kind of lever it out from this end as well, because it's also got a ground plane this side I need to deal with. Okay, that's that side out. This cap could be completely fine. It's entirely possible it is. Right, put the new one in. Height's about the same, isn't it? Height's slightly bigger. Hopefully that's not an issue. I guess we'll find out soon enough. Make sure it's pushed down all the way when I solder it. Solder from the top. Okay, that's that one. So this one here, which we're looking at before, that's a little bit concerning. So it's that 10 microfarad 350 volt. I don't think the 10 microfarad part matters that much. I think the main thing is the 350 volt. So I shall come back and check the jack before I do anything else, because I've only got 2 tantalums and that cap there to do. Right, there we go. And yeah, translate to hourly wage, exactly. You do this sort of work for basically nothing. I do this because I enjoy it, and I do it because of my channel. But if it was a paid job, it'd be a very different story, wouldn't it? It wouldn't be. It'd be kind of uneconomical to repair, which is why these get sold. I saw the HP 8165. That happened in last week's live stream. So you would have seen it live if you're here last week. At the right time, of course. So I'll get rid of that. So let's pop that out for... That's not what I want. These 33s. They go in there. I'll start putting things away, actually. Well, I'll probably find I want a 33 next. What are these caps I'm looking for? Here, somewhere. Is this them? 18 volt 450. Here we go. But it's not. It's not the right size. Did I have one with the right format but higher capacity? 350. I don't think I've got anything that high in this package size. That's 100 volt. What's that on there? I can see something in there actually. What's that underneath all that stuff? What do I have here? Ah! I do have the right cap. 10 microfarad, 400 volt. Sweet, that will go in there. Problem solved. Okay, let's get this one out. I'm going to have to leave it up again like I did the last one. Because of the way they've designed these things. They're glued down. It's not a big deal though. Come on. Come on. Try and get the solder's gone. There we go. Solder's gone. So we'll get the hot glue to go. There we go. It's starting to fail. Come on. Come out. Right. So we get the hot glue off. The actual soldering's taken off. Here we go. Right. Fold the egg so you can read it. I just hope these caps aren't a little bit too big, because they do stick out slightly more than the originals. Not much, millimetre or two. So that's enough though. Cool, that's that done. Got those tantalums yet? Almost forgot. Right. What do we have? So 100 microvolts, 16 volt, and a what? What are you? .7, 16 volt. .725 volt. What did I say these were? 10, weren't they? 10 volt. Yeah. I don't have an upgrade for that one. That one might have to stay. don't like that, but I'm going to have to. I shall mark that one as not done. So I'll just put this one in. All this work just to get to the point where you can turn the thing on and see what else goes wrong. It's a little bit frustrating in a way. Okay. Right. So there's one tantalum here which I can't change, which is a shame. Is there anything else on this board I need to check? A couple of diodes, I've already checked the fuse. I've got a bridge rectifier over here, we'll check that as well. Just in case some other stuff has been going on. Alright. That's fine. A little diode here. Probably alright. Little diode here. Okay, check bridge rectifier. It's good. 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 So the bridge rectifier looks alright. It's a relief. So I think that is basically power supply boards done. That took a while. Who's still here? Then 9 people now. It's going on quite a while, the stream. Where we go to? I need to talk about other stuff still. That's how I like to use solder, okay? That's how to do it. I end up with a massive piece that sticks out and you're holding it, and I don't like to hold the solder directly all the time. Just find my fingers get too dirty. Supercaps, yeah, supercaps are basically very low voltage but really high capacity. And because they've got such low internal resistances, they will hold a charge for ages like a battery will. Very low losses. Right, let's put this power supply board back in again. Can I mark them both as done? Ish. Maybe. I should record a video on it actually, just to say I've done it. So now I'm up to if I need to review anything. It's part of the reason I do videos, so if I need to go back and look at something, I've got it on camera. So I've recapped these two power supply boards. The only exceptions of what I haven't done are those two big capacitors there. That's 325 volt caps, which test okay, but they are marginal as far as voltages go. There's 25 volt caps on a 22 volt rail. So I do want to replace those. On this board, the only other cap I haven't replaced is this tantalum over here, which is a 100 volt, I can't remember what the capacitance was now. It's a 100 volt cap anyway. I need to go and check that out. I don't want to bend it up again. Was it 10 microfarad? Yeah, 10 microfarad, 100 volt. Was it? Or I'm going to have to look. I need to get this right. Where is it? Here it is. 100 microfarad, get it right. 100 microfarad, 16 volt. Right? So 100 microfarad, 16 volt was that cap there, which I don't have in stock. I've only got 10 volts. So I've left the original one in place, because what I put in will be worse than the original. So that cap there, these two here need replacing, otherwise those two boards are done. Replaced all these tantalums, everything else is done. Right. Put them back in again. And you won't be able to see much because I'm over here. So I put these in, then I'm willing to power it up. That's the fun bit. Which is those board edge connectors that look alright. Yeah, I suppose they are. No, there's a little bit of oxidization on those ones. I think we'll have to give these connectors a bit of a clean. Just a gentle clean. These are gold plated, so I don't want to rub these too much with this fiberglass pen. I just want to take the surface coating off because there's a little bit of oxidization on these. I'll give it a wipe with a bit of alcohol. Alright, that'll do. This is actually fairly tidy inside. There's lots of gear I've seen which has been quite bad and dirty inside. This is actually looking alright. So I'm not too worried about corrosion in this one. But there has been other times when it's been a real problem. I'll slot these two boards in at the same time because they kind of mate together. This is when I find out the caps are too big and I get in the way. I don't think it will be a problem. Nah, that's fine. If I slot it in alright. There's no interference there. Excellent. Try and plug these connectors back in again. Try to. Oh, it's tight on there. Super tight connectors. Nearly there. I really want to get this thing powered up before I stop stream. Okay, so the Kent is on. Right. I'm going to power this up on the floor, I think, because it's a bit hard to move around. Get a cable. I'll change the camera around so you can see, hopefully. I'm pretty sure I changed voltages on it. I better check that actually. Before power it up in case I haven't changed it for 240 volts. Better make sure. Yep, I've changed it. Cool. I thought I would have done, but I didn't know if I had or not. Right. So what I need to do is spin this camera around and get a multimeter on that thing so we can see if it's putting out anything. Yeah, exciting time's going to be right. Let's try and get this camera on it. I don't really better see it, it's the only thing. Boom, polarity wrong, but it could be. Got the right shirt on. So, let's get a multimeter down there, hook it up, and we'll see if there's any DC output, which is one of the things that had as a fault. Dropping cables left, right and centre. I'll leave the top open in case it does go bang. I want to be able to see where the bang came from. And live stream is at least recording. Well, it's not recording, but it's live. Okay, plus and minus on the output. I'll put the shield on anyway, just in case. Shouldn't really matter. Volts, no, not really volts, volts. Can you guys see that? Maybe, it's a bit small. I need to see it as well though. Right. So let's turn the power on. Well, it beat. It's got a fail message. Nothing went bang. Let's see if it does anything. Fail 9. Okay. Where's the reset? Go on, where's the buttons? I didn't really use this damn thing. I've only used it a couple of times. So I was playing with it. Let me get over here. Now I can see it. Right. Come on. Reset. There's a reset over there. Why can't I clear the reset? Let's reboot it again. Well, this is doing less than it was before. Before the reset would let me get out of this mode. So, right now, you won't let me do anything. It's actually worse. Imagine that. Let me make sure I've reseated these cards in properly. Or maybe by fixing some parts I've made something worse. Maybe I haven't plugged something in properly. It's also possible. Well, haven't nudged that. Okay. Let's try again. So beep, 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 beep. Let's do 4 beeps. And not resetting. Whereas previously it was resetting, I could actually play with some of the modes and stuff. So it's got worse. Now it could have got worse because I've had it sitting here for a month. Or it could have got worse because I've changed something and didn't like it. Yeah. Anticlimax. That's annoying. Damn. So, what could possibly be wrong? So what I might do is just leave it to sit for a while and power cycle it a few times during the day, and maybe it's a capacitor reforming problem. It's possible because I've got caps which will be sitting here for a while, and maybe they need to be reformed a little bit. And if that's the case, then it might come right. Washing machine in the background, yeah. Where's the washing machine in the background? Worse than me, yeah. It's part of the fun, isn't it? You change the stuff, see what happens. If it doesn't work, keep trying. But like I said, this is going to be as I expected at the beginning, a video series. So this thing's going to be a lot of work. So yeah, no bang though. Yeah, anyway, it's fun. Try these things out. Here's a lot of work here. Well, you see how much work I spent on it today, and I've only done a few boards, and all the boards need the caps doing. I think I've got all the cables plugged in. I'm fairly sure I've got them all right. Yeah. So, anyway. What's error 9? I mean, I know that the fault codes are in the manual. No, there's no sensors I know about. Let's see if I can find the fault codes in the manual. It does mention them. I know it's in there somewhere. In the many pages. It must be an index. Fail 9. Power amplifier, 15 volt power failure. Now, there's each beep I think is an error code. Yeah, the buttons didn't reset, which is the interesting part. So, I think there might be some tantalums on the front panel PCB as well, actually. I think there might have been. I might have to check on that. Because the front panel PCB's got some circuitry on it as well. I haven't checked that one yet. So yeah, fail 9's 15 volt power supply failure, well power failure, PA. Let's go to the top screen so you know what I'm talking about. You know, I could probably string a sentence together if I'm lucky. So, failure codes. So, fail 9 is this one. Thing is, when it beeps, it goes through a series of tests. So, it could be multiple failures. What I was getting before, I think, was fail 5, was it? Fail 2, fail 5. I think those were going before, something like that. So, but I didn't see fail 9 before. So this is a new failure. So maybe I've got something plugged in wrong. PA means power amplifier. So that's one of the output boards. So yes, a lot more fun to come yet. I've been working on this thing for what, 6 hours-ish? Oh, I didn't say 5 hours, probably playing with this thing. So yeah, we're not there yet. It's a shame. We'd like to have seen it powered up and actually do something. But at the moment, we're not there. Now the power amplifier is one of those boards which has got 2 plugs on it, and I may have got those plugs back to front because they're identical. It's possible I got them backwards. Don't know. Let me check see if I had those markings or not. I'm not sure if I've been marked. I don't think I did. So they've got different pinouts. So if you do get them back to front, it doesn't matter. And they're going to transformers. J4 and J5 of the PA board. I need to see where they go to make sure they're hooked up correctly. So going to the transformer on the back, and then the other one goes to the other transformer. So they could be backwards. I'm pretty sure I put them back on right, but I'm not certain. Let me look at the diagrams and see where these go. Just want to be sure. I don't remember. I've got to find the right board. That's always fun, isn't it? Which board's that? Level 5, that's definitely one. That's one of the later boards. We keep going. What's this one? No. Plus he's finding the right board. See it somewhere. this is it. Yeah, power amplifier, here we go. These two 4-pin plugs I'm looking at. Just in case I got these wrong. Or maybe somebody else got them wrong. So we've got J4 and J5. J4 doesn't say much about where it goes. That's helpful, isn't it? Might be within the actual main unit layout. Might say what it is there, but I'm hoping I can determine it from this. This J4 and this J5. So, which one do I bloody go to? There we go, got wild colours. Helpful. Okay, so J5 should have the red. Blue and red should be J5. And it is, so it's in the right way. So I didn't get that wrong. So that's not a problem. Okay. So really the only thing I can do is try and go through errors one at a time, I suppose, but you know, no error 9 is a power supply problem on this section. So it's a 15 volt. So can we find that on the board? Maybe probably have to work backwards rather than forwards, because I believe there's other errors which happened before this one comes up. It's a 400 volt, 38 volt, 15 volt monitor. Here we go. There's a section here. This is what it's not seeing. It's this 15 volt here. This is what the error 9 means, is this bit. So there's LM324, looks like, op amp. Plus and minus 15 volt rails. So if I check those rails and one of them's missing, that could be it. And that is outputting, interestingly, 15 volt fail, J9 108. So it's got an output there, and it's also got, comes over here to MC1401, which is a flip flop, which is doing something as well. Minus 15 volt on here, and a 1 microfarad 35 volt cap. Keep it tantalum. Well, that looks like electrolytic symbol, so maybe not. Okay. So it could be I've got a power supply problem, because this is saying a 15 volt rail is missing. Well, a 15 volt rail is missing because it's checking both of them. So it's a plus and minus 50 volt monitor. There could be multiple triggers of different errors. So probably still power supply problems. It's entirely possible. Maybe something else going there which I haven't detected. So I do need to check voltages on the rails and stuff like that. But I think I've had enough for today. It's been a long day. Yeah, it's basically a comparator. It's checking both rails, so both rails are going across it. So I'm not sure what the power supply will be though, but the Zener diode there, just running through a Zener to drop it. That's minus rails. Not quite sure how it works. Positive, pulling it up. what's your positive? Could be 50 watt rail there as well. So maybe this is 10k, 1k. So you've got a voltage divider happening as well. I can't be asked figuring this out. Cut diodes. Could be one of those diodes. 1M4148. So they do fail from time to time. But then so does the LM324s. It looks like it's a single package doing all four, because I think they're quads, M324s. So 5, 6, 7, 2, 3, 1. So 1, 2, 3, 5, 6, 7. Here's some more. 8, 9, 10, 11, 12, 13, 14. So there's a single package doing the voltage detection across all those rails. So we've got multiple failures for rails. It could be that device has failed, or it could be that device's power supply has failed. Therefore it throws them all out. Possible. Yeah. Okay, so I think power supply rails is what I need to look at on this thing next. Now I've done some basic checking on it and done some basic repairs to fix the obvious faults we know about. I mean, there's other stuff there which we still haven't checked. There's like the power output sections we haven't checked. There's a second supply rail there as well, which I haven't checked as well yet. So there's still some stuff there which could be a problem. Yeah, there's a few other things in there. But if I was to go through and just replace all the tantalum capacitors and all the boards, get all the boards done, or all the electrolytics as well, anyone I find, but do all of that, all the boards are good, so there's nothing dragging it down. There could be a board dragging it down, never know. Could be a cap which is fouling and dragging it. Then once I've done all that, then I can look at power supplies and just be sure that all the boards have good capacitors on. And I'll do a blanket replacement like I intend to do anyway. So I think that's probably my next. It's going to take a while, but yeah, it needs doing. So I think I have to just replace the caps, then check out all this stuff on the power supplies, check all these power rails out. Once those caps are replaced, to rule those out from dragging it down, as I say. And then go from there. But so initially when I did do this thing, it would try and do some outputs, but it wouldn't actually output the DC sections properly. Or anything above, I think it's anything above 10 volts. The voltages are wrong. Anything above 10 volts was completely, it wouldn't do it, or something like that. I think it was something like that. So it's actually worse than it was, but it could just be that now I've resolved the problem, which has then caused a proper sensing failure, like you should have had maybe. Yeah, bare feet, it's fine. My whole house has got RCD protection, so everything, in every room, every power outlet has got RCD protection. So RCD protection is at least present. But yeah, I won't be obviously doing it when it's plugged into power. So I'm going to be figuring that out. So if I'm going to be doing voltage checks, I'm going to do it on the floor, I'll be putting it back over the desk and doing it over here properly. This is just hoping I can just get some life out of it and to show you guys, but we're not there yet. How is on 15 volt power rail? Well, just about every single board is on 15 volt rail. I possibly buy a spare on eBay. No, this was a spare on eBay. That's why I got it for a reasonable price. I actually think I paid a bit too much for it. I think I should have paid about $500 less. But yeah, you know, got an opportunity to get one, so I took it. So, right. So I think that's my next plan of attack, is to just clear my denture off again and do all the recapping of the other boards, recap everything, so they're all done, and then look at power supplies after that and try and trace what supplies may be faulty. thing is, that's what I do though. I mean, Kobe, that's what I do. Is I'm not being ripped off. This is what I do. I buy broken test gear in order to do videos on my channel, and then try and fix it. That's what I do. So it's exactly what I want. If I buy a piece of test kit and it's working properly, that's a disappointment. Do I play with GPS modules for Arduino? No, I haven't. Spare board. Yeah, boards are expensive. To give you an idea, for this thing, there's a guy selling riser cards for this because it's got so many slots stuff. You have to, if you work on the individual boards easily, you need to put riser cards in so you can get the boards above the unit and do testing on the boards, right? Otherwise, all within the chassis. There's a guy on eBay selling boards. Just the riser cards, I think they're about $800 or something like that. Horrendous price just for riser cards. I don't think I've seen any boards for a while, but even now I don't know which board I have to replace. I don't like to do board swapping anyway. I mean, only as a diagnostic symptom. You know, if you which board could it be? If you've got a few, you can swap out one and go, oh yeah, maybe it, you narrow it down a little bit. That's about it. So yeah, but I'll just, I mean, if I need to, like I said, I can actually get this power supply board out. I'll hook up to my power supply over here and bench test it, and I can test each individual power supply off that board. I can just hook them up, and that's why when I did my Fluke 5200A calibrator, that had lots of problems. Every board was failed in that thing, and I'd replaced. I think I repaired the power supply about 6 times because it kept on blowing up. Because another board kept on making it blow. So it's possible. And when I did that one, I had to do that. I had to do multiple power supplies on that power supply card and simulate being in the unit. And now I can actually test the power valve, see what was and was not working, what was getting hot, and that sort of stuff. So this is a far simpler power supply in a way. It's got lots of rails, but it's simpler. So if I need to, I can just hook up to my power supply here and test the power rails individually on my bench and see if they're being generated, and do it that way if I come back to being a power supply fault. But it could be something else. So I've got lots of options. I'm not worried about it all yet. I've got no concerns. It's the nature of working on test gear. It's you fix some stuff and sometimes it will get worse because the fault was being hidden by a secondary fault. So maybe when I got the thing powering up and working before, well, semi-working before, it was because there was a fault which was masking the test system. So maybe the self-test wasn't finding it because of the fault was interfering with it. So now maybe I've cleared a fault, which then makes it appear worse. Don't know. Do I resell devices I repair or keep? It depends. If it's something that I'm going to find useful, I'll keep it. If I have an excess of something, then I'll sell them. Like a good example is those Datron multimeters. So I bought a couple originally. I bought 2, thinking if I can't get one going, I've got 2 chances, and I can use them as cross comparisons. If something different between the 2, I can use that to try and identify what's going on with them. End up fixing them both. So one of them's now behind me up here. The other one's for sale. Then I picked up 2 more because I thought these are cool to work on. And so I've got 4 Datron multimeters. So I only want 1. So the other 3, well, 2 already for sale. 1 I've got to fix yet. So that sort of thing. If I don't need that many things, then yeah, I'll flick them off. But I do like to have redundancy. So I like to have more than one item. So I have the Fluke 5200A, which is an AC calibrator. Behind me, right here, that's a Valhalla AC calibrator. So I've got 2 calibrators. Now I've got 3 once I get this one working. For AC, I've only got 1 DC calibrator. This will be my second one. I've got 1 resistance calibrator. This will be my second one. So I try and have various bases covered. Multimeters, I've got loads of multimeters. But now I've got, up here is my Solartron. That's a 7.5 digit multimeter. It doesn't seem like the calibration's very good, but it's working. And above that I've got a 6.5 digit multimeter, and so Datron is a 6.5 digit multimeter. Plus I've got my Siglent STM3065X, which is also a 6.5-digit multimeter. I've got 3 oscilloscopes over here. Only one 4-channel one though. That's the reason I've got 3, because I wanted to have a 4-channel scope as well. Very handy to have 4 channels sometimes. Plus, having 3 scopes means you can be testing different things at the same time and not have a cluttered screen, because you can put each one on a different screen and you know what you're looking at on each one, instead of trying to make up, we've got overlapping traces and stuff. It just gets messy. Yeah, well, I can actually load it up as well though. I've got a DC electronic load, so I can load the power supplies. I've actually got 2 DC electronic loads. I've got a Siglent SDL1020XE, which I've hacked, so it's now a SDL1030X. No comment. And I've also got what's the other one? Mayonu? I don't know how you pronounce it. But it's also a 300 watt DC load as well. So I've actually got 2 DC electronic loads I can use to load down the power supply and check them as well. So I can simulate being inside a unit. I can load down multiple supply rails and sort of thing. Yeah, you can get scopes which output like a VGA output or HDMI output. You can get some. The Siglent ones have got, I think, the Keysight as well. You can use the remote monitoring on them, so you can actually view them on screen, on a PC at least. As I use a Mac, I can't really do that. It doesn't work very well, or at all, depending on what you're trying to do. So you can actually do remote control and remote viewing on a computer of the scopes using the Ethernet ports, so you can network them. So you can have it on the computer and do it on screen. I could just do it as a window and actually insert it on this video, for example, if I was doing that. If I had a PC. I don't. Well, I do have a PC, but it's a laptop and it's not great. I only use it for random testing of things. Right. So, today wasn't a waste. I did some stuff, found a fault, and we've got more work to do. So, like I said, plenty of videos and this thing's going to be coming up. So thanks everyone dropping by. I'm going to cut the stream off here. I'm kind of tired of talking. Throat's getting pretty sore. And I need to tidy my room up and go through these cards and maybe do some more video fixing these cards. Maybe just skip through, so I'm fixing this one, just try and do bits and try and edit it down. So, right, thanks for dropping by. Don't forget to give us a thumbs up if you liked it, and if you're dropping by later on after the stream, you're not really subscribed, then make sure you subscribe, click the bell icon, that sort of stuff, and I'll catch you in future videos. And watch out for the video series on this Calibrator. When I do dig into it, you'll see the proper videos, which are nicely edited, as nicely as I can do, and you might see a bit more focus on it, and see what's going on, hopefully. Alright, thanks everyone for dropping by. I'll catch you all later.